are here to keep a record of the longest mathematics lesson ever, and which will last for 30 hours. So here with me, we have pharmacists. As witness, we have pharmacist Mugen Danjuma and Comrade Malay John. So we are going to set this record in mathematics. And we have a list of topics to cover. We have a list of topics to cover, and on the list, the first topic is fraction. But first, what is mathematics? Mathematics is the abstract of numbers. That's where they want us to dwell. That's the Guinness World Record say we should dwell in the abstract of numbers and quantity plus space. So we are starting with fraction. We are starting with fraction. Let me just read a theory part before we do the calculation. Now, definition of a fraction. Fraction means part of a region or part of a group. Fraction means part of a region or part of a group. Let's take an example. This is a circle. And this circle is divided into two. The circle is divided into two and two equal parts. So this is the first part. Let's shade it. So this is the first part, and this is the second part unshaded. Now, if you are asked what is the fraction of the shaded portion in this diagram, this side, what is the fraction of the shaded portion? That's the relative to the shaded portion. We have only one portion that is what shaded. So the fraction will be, since we have two parts, that's the total part. The fraction will be 1, the part of the shaded, divided by what? 2. That's the fraction. And you are asked, what is the fraction of the unshaded portion? How many parts do we have that is unshaded? 1. So the fraction of unshaded portion is also 1 over 2. This is the basic definition of fraction. So now we have, now we want to know what this fraction is all about. The number at the top is called what? The numerator. The number at the top is called the numerator. And the number at the bottom is called the denominator. So we have word problems under fraction. But before we go into word problems under fraction, first, let me define some terms for you. We have improper fraction. Improper fraction. What do we mean by improper fraction? Improper fraction are fractions that have the numerator is bigger than the word denominator. You know, here we have 1 as the numerator, and 1 is lesser than what? The denominator, because the denominator is what? 2. So here is a proper fraction. This is a proper fraction. So if the denominator is bigger, if the numerator is bigger than the denominator, then we call it improper fraction. That is, if we have something like 3 all over 1, or let's say all over 2. 3 all over 2 is an improper fraction. So, but there is a way we can convert this improper fraction to what? A proper fraction. And how do we do that? I'm just telling you the basics before we enter into the calculation part. We have if you want to convert this to a proper fraction, you will now divide this 3 by 2 with the remainder method. So 2 go into 3 how many times? 1. Remainder 1. So we have 1 whole number. The remainder is what? 1. Then you put the 1 here all over what? 2. So you have converted it to what? This one is the whole number. This one is called the whole number. So any number that is not a whole number, then we can call it what? A fraction. That's numbers that have numerators and denominators. So now let's go into word problems under fraction. Now here we have a question. It says if a particular number is added to the numerator and the denominator of 3 all over 18. If a particular number, and this number you don't know the number. So if a particular number is added to the numerator and the denominator of 3 all over 18, the resulting fraction is what? 1 all over 12. Which number was added? Now first, since we don't know the number, we can call the number x. Let's just give it a symbol x, a letter x. So let the number be x. Now let's read the statement again. If a particular number is added to the numerator and the denominator, so this number is added to both the numerator and the denominator. So and they say the number is 3 all over 18. Is added to a denominator of a fraction 3 all over 18. So this is 3 all over 18. And a number x is added to what? Both the numerator and what? The denominator. So according to that statement, it means our fraction will change to what? 3 plus x. 3 plus x. All over what? 18 plus x. So now, and they said the resulting fraction is 1 all over 12. So now the resulting fraction of the resultant of this fraction is called what? Is 1 all over 12. So now this forms what? An equation. This is now an equation. So now to solve this equation is either we cross multiply. Let's cross multiply. Cross multiply this, we have what? 12 will multiply everything on the numerator, everything here, the numerator. 12 is multiplying the numerator. So we put 12 in bracket 3 plus what? X equal to, now 1 will multiply what? 18 plus x, and 1 multiplied by 18 plus x, you know anything multiplied by 1 is still that number. So we have what? 18 plus x. Now we have a problem here which we need to expand this particular bracket because there's a number multiplying everything in the bracket. So now 12 will multiply 3 first, then 12 will multiply what? X. So 12 times 3, then the sign plus 12 times what? X equal to 18 plus what? X. Now what is 12 times 3? 12 times 3. Someone should stand up. It's a lesson, so it has to be interactive. 36. So we have 36 plus 12 times x is 12x equals 18 plus what? X. So now we have like terms here, so we are going to collect what? Like terms. Those terms that are having x will go to the left hand side, and those that are not having x will go to the right hand side. So now 12 is already in the left hand side, so x will come, and whenever, or we can say subtract x from both sides. You can use either method. It's either you say subtract x from both sides, or you collect like terms directly. So if x crosses over here is what? We will have 12x minus what? X equals, here 36 will cross over and it will change to what? Negative, because it's having a positive sign. So we have negative what? 36. 12x minus x is what? 11x equals 18 minus 36. 18 minus 36. Stand up and this record is all about the host and that's the tutor and the participant. The tutor and the participant. So okay, minus 18. So we have minus 18. Then what next? What are we to do here? How much should we stand up and tell us? What next? We have 11x equals minus 18. 11x equals minus 18. So what are we to do here? If you know, just raise up your hand and stand up and tell us. 11x equals minus 18. It has to be interactive between you and I, and everyone has to contribute. That's why it's called a lesson. Okay. We'll divide both sides by 11, not 11x. Because we are trying to find what? X. So dividing both sides by what? 11, we have x equals minus 18 all over 11. Minus 18 all over 11. Someone should tell us how to break. Okay, what's this type of fraction called? From the initial explanation, we have 18 all over 11. 18 all over 11. So what's the name of this? Someone that has not spoken to stand up and tell us.
Improper fraction.
Okay, improper fraction. Improper fraction. So now, let's convert it to a proper fraction. So 11 will go into 18 how many times? 11 will go into 18 how many times? Someone, a different person should stand up. 11 will go into 18 how many times? How many times will 11 go into 18? We have one time, remember what? 7. One time, remember 7. So x is equal to negative 1, remember 7 all over what? 11. So we're starting from the basic before we go into the complex. So now, we have another question similar to this. Now, if a particular number is added to 3 all over 5, if a particular number is added to 3 all over 5, and the resulting fraction is 1 all over 2, what is the number? If a particular number is added to 3 all over 5, the resulting fraction is 1 all over 2. So the resulting fraction is 1 all over 2. So someone should tell us what is the first thing to do here. Participant. The first thing to do. The first thing to do is let the number be what? Let the number be what? Y. Let's choose Y. Let the number be Y. So if the number is Y, we have 3 plus what? Y all over 5 plus Y equals 1 all over what? 2. So next thing to do is what? The next thing to do is what? Yes, stand up and say. And you are talking, stand up. multiply what? 3 plus y. Then we have 5 plus what? Y. Now opening the bracket, we have what? 6 plus 2y equals 5 plus y. So collecting like terms, we have what? We have 2y minus y equals 5 minus what? 6. Now y is equal to what? Negative 1. Y is equal to negative 1. Now, since you know the basics about this, let's move to, since it's a lesson, let's move to change of subject formula. Change of what? Subject formula. Change of subject formula. Change of subject formula. Now the subject of a formula is the variable that is being worked out. It can be recognized as the letter on its own on one side of the equality sign. Now, sometimes, for example, let's take example with this formula. F is equal to G M1 M2 all over what? R squared. This particular formula. And F is already the subject formula. What we mean by subject formula is that that particular variable will stand alone as the what? Rather, it will be the defining factor of the whole formula. So this F is already the subject formula. But there will be a situation whereby the F will be given and G will not be given. F will be given and G will not be given. And whenever G is not given and F is given, M1 and M2 are given, R is given, then we have to change the subject formula to G, which means G will come to this. So we'll look at it. Just the basic thing is just to cross multiply and cancel out some things. That's all. So here we have what? Fg. Let's assume we are asked to find we are asked to make G the subject formula. So we have F equal to G M1 M2 all over what? R squared. So we want G to stand alone. So what? Cross what? Multiply. Now F will multiply what? R squared to give us what? F R squared. Then already this F has a denominator of what? 1. So the whole thing here is multiplying 1. So we have what? G M1 M2. So now, what are we going to do to make G stand alone? From here, there is a multiplication sign binding this particular term. So this multiplication term, we can only cancel this M by what? Dividing 2. So let's divide 2 by what? M1 and what? M2. Dividing 2 by M1 and M2, we have M1, M2, M1, M1, 2. So M1 cancels what? M1, M2 cancels M2. So now we have what? G equal to F R squared all over what? M1, M2. So we have successfully made G the subject formula. So G is the subject formula. Now, in the another example, in the formula for the area of a rectangle, A equal to BH, that's base times height. The subject formula is what? A. So they say in the formula for the area of a rectangle, A is equal to, A is equal to what? BH or LB. That's length times breadth, or base times is what? Height. So in this formula, the subject formula is what? Who can tell me what is the subject formula? What is the subject formula here? Okay. A is the subject formula. So we have A equal to BH. And what are we going to do to make B the subject formula here? No. We are having B multiplied by what? H. What are we going to do here to make B the subject formula? Yes, divide both sides by H. So dividing both sides by H, we have A all over H, BH all over what? H. H cancel H. And we have what? B equal to A all over what? H. So now B is the what? Subject formula. B is the subject formula. Now, question 2. Given T equals A plus N minus 1 close bracket D. Given T equals A plus in bracket N minus 1 close bracket D. We are asked to what? Make A the subject formula. This one is very simple. We are asked to make what? A the subject formula. So what are we going to do? Making A the subject formula is make A stand alone. Make A stand what? Alone. So what are we going to do to this expression to make A the subject formula? Now, this is a term on its own. So we'll just subtract what? We'll subtract N minus 1 multiplied by D. We'll subtract it from what? Both sides. So subtract in bracket N minus 1 D from what? From both sides. So T, subtracting from both sides, we have what? Minus what? In bracket N minus 1 D equals A plus what? N minus 1 D minus what? In bracket N minus 1 D. So this one cancels what? This one. Subtract, because if you subtract this and this is 0, you are having 0. So we have T minus what? N minus 1 D equals A. So which means A is equal to what? T minus N minus 1 D. So here A is the what? Subject formula. A is the subject formula here. Now, what if you are asked to find? You are asked to make N the subject formula. If you are asked to make N the subject formula, what are we to do? That's from this same example. You are asked to make N the subject formula. Now we have what? T equals A plus in bracket N minus 1 close bracket D. We will simply what? Multiply D to open this one bracket. So we have T equals A plus D multiplied by N is what? N D. Now D multiplied by minus 1 is what? Negative D. So now let's collect that term. Let's leave n alone. We have t, we subtract a from both sides, and we also add d to both sides. So subtracting a from both sides, we have what? T minus a, and adding d to both sides, we have what? Plus what? D equals a plus nd minus d minus a plus d. So t is equals, okay, t minus a plus d equals nd. So we have nd equals to t minus a plus d. What are we to do to make n the subject formula from here? What are we to do to make n the subject formula? We'll divide through by what? D. All over D. All over what? D. Which is equal to n. N is equal to t minus a plus d all over d. All over d. All over d. So this is all about change of subject formula. Change of subject formula. Let's solve another example. Example 2 says, given the equation 1 over f, I want you to work it out. Given the equation 1 over f, given the equation 1 over f equals 1 over v plus 1 over u. Make v the subject formula. Make v the subject formula. Given the equation 1 over f equals 1 over v plus 1 over u, make v the subject formula. And we have 5 minutes of working task. 5 minutes to classwork, every 1 hour. So let's solve it. One all over what? F equals 1 all over V plus what? 1 all over U. 1 all over F equals 1 all over V plus 1 all over U. Make V the subject of the formula. Now, first we'll subtract what? Subtract 1 over U from both sides. 1 over F minus what? 1 over U equals 1 over V plus 1 over U minus 1 over U. So we have 1 over F minus 1 over U equals 1 over V plus 0, because this 1 over U minus 1 over U is what? 0. So we will find the LCM of this, which is FU. FU divided by F is U. U times 1 is what? U minus FU divided by U is what? F. F times 1 is what? F equals 1 over V. Now cross multiplying, we have V multiplying U minus F equals FU. Then now to get V, we'll what? Divide 2 by U minus what? F. So V U minus F all over U minus F equals FU U minus F. So this cancels what? V. Then we have V equals FU U minus what? F. So here we have V equals FU all over U. So V is now what? The subject formula. V is now the subject formula. Now we will move to what? Simplification of brackets. And we have done some of these simplifications in the previous examples. So simplification of brackets. To simplify an expression means that you are writing an algebraic expression in a form that is easier to use if you want to do something else with the expression. Now, simplification of brackets in an expression implies the expansion of bracket. We can remove bracket from an expression by what? Expanding it, just the way we did here. We expanded it and we got this. So hence we use the distributive law of multiplication over addition or subtraction. Generally it is written as x y plus z equals, now expanding this will have what? X times y, we have x y plus what? X times z, we have x z. That's just the expansion. If you want to remove bracket, you use what? You expand it, you multiply the number of variables outside with the bracket using distributive law, multiplicative law. So let's expand this. Let's expand 9 open bracket 5 plus what? Plus 3. Expand 9 in bracket 5 plus 3. To expand this, we have what? 9 times what? 5 plus what? 9 times what? 3. So 9 times 5 is what? 9 times 5. 9 times 5. 9 times 3 is what? 27. So we have 45 plus what? 27. So 45 plus 27. This is the expansion, and we did it in the previous example. So expansion of what? Perfect. We have expansion of perfect squares. Expansion of perfect squares. Let's take example with this. X minus what? X, we have x minus y squared. X minus y squared. So expand, the following are known as perfect squares. For example, if you are told to evaluate 4 raised to power, that's 4 squared. If you are told to evaluate 4 squared, what is 4 squared? 4 times 4. So if you are asked to evaluate 4 squared, we have 4 times 4, which is equal to 16. So the numerical value above is known as an index. So now let's expand x minus y. X minus y squared is still the same thing as what? X minus y, x minus y. So now x multiplied by x is what? X squared. Now x multiplied by y is what? X y. Now y multiplied by x is minus what? Xy. Then negative y multiplied by what? Negative y multiplied by negative y is y squared. So we have x squared minus what? 2xy minus y squared. So this is the expansion of what? X x minus y all into bracket squared. So let's try to expand x plus what? Y. X plus y squared. Now x plus y squared, following the same method, we have what? Two brackets here. X plus y and x plus what? Y. Now x multiplied by x is what? X squared. X multiplied by y is what? xy. Y multiplied by x is what? xy. And y multiplied by y is what? Y squared. So we have x squared plus 2xy plus y squared.
Short line all over the world.
Now, meaning of substitution. As stated at the beginning, a simplified expression is written in a form that is easier to use in certain situations. If you want to substitute x with minus 2, for example, you will choose to write 9x minus 5x minus 8x plus 10x as 6x. Now, let's talk about substitution. Example, we have if x is equal to minus 2, solve 1 minus x plus x squared. If x is equal to minus 2, solve 1 minus x plus x squared. So we are told that our x is equal to what? Minus 2. And substitution means to replace, anywhere you see x in a given equation, you replace it with what? Minus 2. That's substitution. So now we have x equal to what? Minus 2. Now this expression says 1 minus what? X. And our x is what? Minus 2. So in bracket minus 2, because we are having another minus outside. So we have to put it into inside bracket. So we have negative minus, we have 1 minus, open bracket, negative 2, then plus, we have what? X squared. Our x is what? Minus 2. We have minus 2 squared. So here 1 minus times minus is what? Is plus 2, then plus minus 2 raised to the power 2. What is minus 2 raised to the power 2? Minus 2 raised to the power 2 is minus 2 times what? Minus 2. Minus 2 times minus 2. So minus 2 times minus 2 is what? 4. So we have 1 plus 2 plus 4, which is what? Which is equal to 7. That's substitution. Substitution is replacing the value of the variable. You are replacing the variable with the value you are giving in the example. So let's take another example. Let's take another example. Example 2. If P is equal to 3, solve P equal to P minus 7 all squared. If P is equal to 3, solve P equal to P minus 7 all squared. Here we can choose to substitute the value of P and solve. Or we can what? Expand this what? Bracket and solve. So let's expand the bracket. We have what? P equal to P minus 7 all squared, and P is equal to, now we have double bracket here, so we have P minus 7, P minus 7. So P equal to P times P is what? P squared. P times minus 7 is what? Minus 7P. Minus 7 times P is what? Minus 7P. Then minus 7 times minus 7 is what? Plus 49. So we have P equal to P squared minus what? 14P plus 49. So P will go to the other side. We have what? P squared. We have P squared. We have P squared minus 14P plus 49 minus what? Minus P. This P will move to the other side. Equal to what? 0. Because P, if P leaves this place, we are having an empty. So we have 2 here. We have 0. Then P squared minus 14P minus this P plus 49 equals 0. P squared minus 14P, 14P minus 14P minus P is what? Minus 15P. So minus 15P plus what? 49 equals 0. So knowing this, we will see how we can solve simple equations with this. A simple equation or a linear equation is any algebraic equation with one unknown. One unknown. That's a simple equation. And example is solve for P in the equation P minus 7 equals 24. Now solve for P in the equation P minus 7 equals 24. Solution. We have P minus 7 equals 24, and we did this previously. So what are we to do here? If we want to solve for P, solving for P, I said we will subtract 7 from both sides, make P stand alone here in the left hand side. So subtracting P from both sides. We have what? P minus 7, then minus what? P. No, sorry, subtracting 7 from both sides. We have what? P minus 7, then what? I'm sorry. Remember this, this 7 is carrying a what? Negative sign. So to cancel 7 there, we'll add, not subtract. So we'll add 7. We will add 7 to both sides. Add 7 to both sides. So we have plus 7 here equals 24 plus what? 7. 24 plus 7. Then P is equal to 24 plus 7 is what? 21.
What if we are now 7 crossover equals to and it changes the plot?
It's still the same procedure. It's either we collect like times or we subtract, or we add 7 to both sides. So either collecting like times, like I said earlier on, I said it's either you collect like times or you use the subtraction and addition. So let's move to simplification. Simplification. I'm teaching you the basics first before we enter the applications. So simplification. Okay. We have a question that says simplify 16 all over 81 raised to power 1 all over 4, then all over 9 all over 16 raised to the power of 2. So we can replace 16 with what? 4 raised to the power of 2. We can substitute 16. And I told you how to substitute. So now anywhere we see 16, we'll put what? 4 raised to the power of 2 all over 81. And we can still break this 81. 81 is the same thing as what? 3 all over what? 4. And 3 all over what is what? 3 times 3 times 3 times 3. So we substitute 81 with what? 3 raised to the power 4, because we are asked to simplify it. So we have 3 raised to the power 4, close bracket, divide by, we have 9 and 16. 9 and 16. So 9 can be written as what? 3 all over what? 2 raised to the power 2. So we have 3 raised to the power 2 all over what? 16. And 16 is what? 4 raised to the power 2. So we have 4 raised to the power 2. Yeah, 4 raised to the power 2.
Power. I think this is what is this? After the bracket.
Yeah.
After the bracket. We have the first one is 16 is 16 or 81, right?
This is
power
81. Yeah.
But you need to do 1 over 4.
Okay, 1 all over 4 and negative 1 all over 2. Thank you. So if you check this 4 over 2 is still the same thing as 2 raised to the power 3 raised to the power 4 raised to the power 4 and 3 raised to the power 4 divided by 3 raised to the power 2 all over 4 raised to the power 2 negative 1 all over 2, 1 all over 4. It means this 4, since the numbers here are raised, all the numbers here is raised to the power 4, 4 can what? Go out of the bracket. So we have 2 all over what? 3, then 4 times 1 all over what? 4. This particular 4 will go outside. Then we have divided by what? 3 all over 4. And we have 2, 2. So 2 will also what? Go out. And we will be left, we will have 2, sorry, we will have 2 times negative 1 all over 2. Now simplifying again, we have 2 all over 3. 4 times 1 all over 4 is what? 4 all over what? 4. Then divide by 3 all over 4. 2 times negative 1 is negative 2. Divide by what? 2. So 4 divided by 4 is what? 1. We have 2 all over 3 divided by, this is 3 all over 4 negative 1. So this 3 all over 4 negative 1 is the same thing as what? It's the same thing as 4 all over 3. It's just the same thing as this 4 all over 3. But we are still having a division sign. And to change this division sign into multiplication sign, 3 will what? Go up again. So we have 2 all over 3 times 3 all over what? 4. So 3 times 2 is what? 3 times 2 is 6. 3 times 4 is what? 4. And 6 into 6 is what? 1. And 6 into 12 is what? Is 2. So our answer is what? Half. The answer is half. The answer is half. Example 2 is to simplify 3 all over 5 divided by 2 all over 7 times 4 all over 3 times 4 all over 9. So solution 3 all over 5 divided by 2 all over 7 times 4 all over 3 times 4 all over 9. Now let's multiply out. 2 times 4 is what? 8. 8 times 4 is what? 8 times 4 is 32. So 32 all over 7 times 3 is 21. 21 times 9 is 189. So we have 189. And remember earlier on I said to change division into multiplication will work. The denominator will go up and the numerator will come down. So we have 3 all over 5. Division will change to multiplication. So the denominator will go up 189 divided by what? 32. So now we have 3 times 189, which is 567. 567. Then we have 5 times 32 is 160. 160. So this is our answer. Now another example. Example 3, we have if 32y minus 3y equals 14. 32y minus 6 into bracket 3y equals 14. So let's solve this. We have 32y minus 6. So we have to expand this. Now we are using the knowledge of that expansion. You see how we are bringing out all these knowledge we have been acquiring from the test topic fraction. So now we are using expansion. So now to expand this, we have what? 6 times 3y. What is 6 times 3y? 18y equals 14. So now 32y minus 18y. 32y minus 18y. I said 32y minus 18y is simply 32 minus 18. So what is 32 minus 18? 14. So 32y minus 18y is what? 14y. We have 14y equals 14. So we have 14y equals 14. We want to find y. What are we doing here? To find y. We want y to stand alone here. What are we doing? Okay, divide both sides by what? 14. Now 14 cancels 14 and y is equal to what? 1. Because 14 divided by 14 is what? 1. example 4. What is the product? What is the product of 27 all over 5 minus 3 in bracket -3 and 1 all over 5? What is the product? Now we are asked to multiply this and what? This. So we have 27 all over 5 minus 3 raised to power -3 multiplied by what? 1 over what? 5. This is -3. I know this 3 is all over 1. Any number standing on its own is what? Assumed to be divided by 1. So to remove this negative sign, 1 will go up and 3 will come down so that we won't have what? Negative sign here. So we have 27 all over what? 5 minus 1 over 3 raised to power 3. Then multiply by 1 over 5. So what are we to do here? We have 1 over 5, multiply everything inside what? The bracket. So 1 over 5, we have 27 over 5 times what? 1 over 5 minus 1 over 3 times what? 1 over 5. So now 1 times 27 is what? 27. 5 times 5 is what? 25 minus 1 over 3 raised to power 3. It means 1 over 3 times what? 1 over 3 times what? 1 over 3. And 1 times 1 times 1 is what? 1 over 3 times 3 times 3 is what? 27. So we'll replace it here. 1 over 27 times what? 1 over 5. So 27 over 25 minus what? 1 times 1 is what? 1 over 27 times 5 is what? 135. So we have 135. So if you simplify, if we divide 27 over 25 minus 1 over 35, because we cannot reduce this, we cannot reduce it. So we can only divide it. 27 over 25 minus what? 1 over 35. So someone should punch it on the calculator. 27 divided by 25. 27 divided by 25. Stand up. 1.08 minus 1 over 35 is what? 1 divided by 135. 1 divided by what? 0.008. And if we subtract 1.00, 0. What? If we subtract this, we'll be left with 1.0726, which is what? Approximately 1. Which is approximately 1. So, acquiring this knowledge, we'll move to the main topic that will need all these expansions and simplifications, and substitution. So, our next topic is indices. indices. Now indices. Earlier on we were doing some calculations with powers, like 2 raised to power 2, or maybe x raised to power 2, and all these powers are guided by certain laws, and these laws are called what? Laws of indices. And law 1, the first law of indices says that if a raised to power x is multiplying a raised to power y, the resulting the answer is what? Will be a raised to power x plus y. A raised to power x times a raised to power y will be what? A raised to power x plus y. It means when certain variable, like when a variable, if we have two the same variables multiply themselves and they have powers, the powers what? Automatically add themselves. So a raised to power x times a raised to power y is equal to a raised to power x plus what? Y. A raised to power x plus y. Which means if we have a raised to power 2 multiplied by a raised to power 3, then we will have what? A raised to power 2 plus 3, which is what? A raised to power 5. That's just the law. As simple as this. So a raised to power x times a raised to power y is a raised to power x plus y. Now the next law states that a raised to power x divided by a raised to power y. This one is a raised to power x times what? A raised to power y, which is a raised to power x plus y. The next one is a raised to power x divided by a raised to power y. Is what? A raised to power x minus y. That's the second law. And same thing here. If we say a raised to power 2 divided by what? Let's say a raised to power 3 divided by what? A raised to power 2. Then we have a raised to power 3 minus 2, which is what? A or raised to power 1. N1. So a raised to power 1 or what? A. Because it's automatically, any variable standing on the goal is automatically carrying a power 1. So a raised to power 3 minus 2 is what? A. Now the third law states that if we have a to the power of x in bracket raised to power what? Y. A raised to power x all in bracket raised to power y. Then is equal to what? A raised to power x y. Which means the power multiply themselves. So x will multiply what? Y. And we'll have a raised to power what? X y. Comparing with this, we have what? A raised to power 2 in bracket raised to power 3. So it means a is equal to what? 2 times 3, which is 6. Which is 6. Now the fourth law is a raised to power 0. A to the power of what? 0. A to the power of 0. And anything to the power of 0 is what? 1. Then in the same vein, we have a raised to power 1, which is equal to a. Like we stated it here earlier on that a raised to power 1 is what? A. So anything, if you have a variable x, it's automatically carrying what? A power of 1. But we don't just write it. So any variable standing on its own is automatically carrying a power of what? 1. So the fifth law states that when we have m root same thing as what? A raised to power m all over what? N. If we have m root of a raised to power n, we automatically have a raised to power m all over what? N. Which means if we have square root of a, what will it give? You know this one is automatically carrying what? The power of 1. And this says square root is having what? 2. So which means we have what? A 1 all over what? 2. So if you have cube root of m raised to power 5, it means what? We have m raised to power 5 all over 3. 5 all over 3. Then 6. The 6 closest is that if we have a divided by b raised to power m, it's still the same thing as what? A raised to power m all over what? B. Sorry. B m. Because the power, all the variables inside the bracket must carry this power. Example, if we have x, y in bracket m, it's the same thing as what? X raised to power m and y raised to power m. So same thing with the division. X all over y raised to power m is the same thing as what? X raised to power m all over y raised to power m. So number 7, we have this is automatically another loop which states that what? A, B raised to power n is equal to what? A raised to power n, B raised to power n. So below 8, if x raised to power a equals y raised to power b, then that's if x raised to power a is equal to y raised to power b, then we have x, then a is equal to what? B. Whenever x is raised to power a and y is raised to power b, and they are equal, then automatically it means a is equal to what? B. So example, example 2 raised to power 3. Example, if 2 is raised to power, if we have 2 raised to power 3 and we say it's equal to what? 2 raised to power b. We have 2 raised to power 3 and we say 2 raised to power 3 is equal to 2 raised to power b. Then what is b? What is b? It means b is equal to 3. See here, x raised to power a, y raised to power b. If they are equal, then a is equal to what? B. So 2 raised to power 3 equals 2 raised to power b. Since they are equal, then b is equal to what? 3. Now, below 9, x raised to power a is equal to y raised to power a. Then, whenever we have x raised to power a and y raised to power a, then automatically x is equal to what? Y. Same as this, they are similar to this. This is similar to law 8. Law 8 is telling you that the powers will be equal whenever x is raised to power a and y, x x raised to power a is equal to y raised to power b. Then we have a equal to b. Then this one is saying x raised to power a, y raised to power a. If they are equal, then automatically we have x equal to y. So x will automatically be equal to y. Let's say this is 3. This is 3, a raised to power 3. Then we have b raised to power. Then we have 2 raised to power 3. A raised to power 3, 2 raised to power 3. So what is a here? What's the value of a? The value of a is 2. The value of a is 2 because from this loop it says if the powers are the same and the variables are equating themselves, then automatically the variables are equal. The two different distinct variables. So x raised to power a equals y raised to power a. Then we have x to be equal to y. So let's solve some examples. Now, example 1, we have 2a squared times 5a into bracket 3. 2a squared times what? 5a in bracket raised to power 3. 2 times what? 5, 3. 5a times what? 5a times what? 5a. And 5 times 5 times 5 is what? Is 125. So it's 125 and a times a times a is what? A cubed. A raised to power 3, which means there are 3 a's here. So a raised to power 3. So we'll bring it here. 125 a raised to power 3. Now, this number, this is a number, this is a variable. So we multiply this number and 25. What do we have? 250. So we have 250 times what? A squared times a cubed. This is this group. Are you seeing it? This is automatically the first group. So from the first one, it is a raised to power x times what? A raised to power y. We have a raised to power x plus y. So here we have a raised to power 2 times what? A raised to power 3. Which means we will have what? A 2 plus what? 3. According to this. Now, a 2 plus 3 is what? A raised to power 5. So we have 250 times what? A raised to power 5, which is equal to 250 a raised to power 5. So the second example is cube root of 8a raised to power minus 6. Cube root of 8a raised to power minus 6. So who can tell me the law to use in this particular question? Just look at it and compare it with these two, all these laws stated here. Just tell me the law number 5. Law number 5. So, and law number 5 says if m root of a to the power of n, we will have what? A raised to power m, the the value here divided by what? The power of a. So we have the power of a here to be what? Minus 6, and the value here is what? 3. So this automatically means that 8a, sorry, we are having another number here. So anything that is happening to a must happen to what? 8. So we put it in bracket. 8a minus what? 6 in bracket. Raised to power this 3 will come here and be turned to 1 over what? 3. It will automatically turn to 1 over 3. 1 over 3. 1 over 3. So 8, we can transform 8 to be 2 raised to power 3. 2 raised to power 3. Because 2 times 2 times 2 is 8. So here is 2 raised to power 3. A raised to power minus 6, all in bracket, raised to power 1 over 3. Don't be lost because of this 1 here. You know, we're supposed to divide this minus 6 with m, and our m here is 3. But anything that this a is carrying is having a coefficient. So anything that's happened to a must happen to what? Is coefficient. So we have what? Let's multiply 2 by what? 1 all over 3. So 3 all over 3, that's multiplying. Let me break it down. So 2 raised to power 3 times 1 all over 3. Multiplied by what? A raised to power minus 6 times 1 all over 3. Now, 3 times 1 all over 3. Remember the simplification we did. 3 times what? 1 all over 3 is what? 3 times 1 all over 3. From the simplification we did, 3 multiplied by 1 all over 3 is 3 times 1 is what? 3 all over 3, which is what? 3 all over 3 is what? 3 divided by 3 is what? 1. So we have 2 multiplied by what? A to the power of minus 6 times 1 all over 3. And minus 6 times 1 all over 3 is what? Minus 6 times 1 all over 3. Minus 6 times 1 is what? Minus 6 all over 3. 6 divided by 3 is what? 2. With the minus, we have negative 2. So minus 2. So remember that it's a row. Okay, we didn't even write the 10th law. That's the inverse law. If A is carrying a negative sign, like A raised to power negative n, A raised to power negative 1 is equal to what? 1 all over what? A. So here we have what? A raised to power negative what? 2, which is equal to what? 2 times what? 1 all over what? A squared. This law can also be written as A negative n is equal to what? 1 all over A n. So we remove the minus, we'll push this A with the power, the denominator. Now we have 1 as the denominator. So this particular law is this. So A raised to power minus 2 will give us 1 all over what? A squared. So 2 times 1 is what? 2 all over what? A squared. That's the answer. Next we have cube root of 8a minus 6. Sorry. Cube root of 4 raised to power 1.5. Cube root of what? 4 raised to power 1.5. 5. And what is 1.5? 1.5 is 3 over 2. If you divide 3 by 2, you have what? 3 divided by 2 is 1.5. So we will now substitute. Remember initially we did substitution. So anywhere we see 1.5, we'll put what? 3 over 2. So this will give us cube root of 4, 3 over what? Cube root of 4, 3 raised by 3 over 2. Now this cube is this loop. This particular expression is what? This loop, m root of a raised by m, and a root and this will automatically change to what? 4 to the power of 3 over 2 multiplied by 1 over 3. And 4 is the same thing as 2 raised to power 2, all in bracket 3 over 2 times 1 over 3. And is equal to 2 times 3 is what? 6. 6 times 1 is 6. All over 2 times 3 is what? 6. So 6 all over 6 is what? 1, which is equal to what? 2 raised to power 1, or just 2. So let's solve another one. We have what? 5x equals 80 x raised to power 1 over 2. So let's divide through by what? 5. Dividing here by 5, we have what? 5 here, 5 here. So 5 cancel what? 5. And we have x equal to 80 over 5 times what? X negative 1 over 3. Then we will now what? Divide through by x negative 1 raised by negative 1 over 3. We'll have x over x negative 1 over 3. Then here we'll have what? 80 divided by what? 5. And what's 80 divided by 5? Do it on your calculator. Then x divided by what? X raised to power 1 over 3 equals to 16. 16. So this is division. This is the loop. And it says a raised to power x divided by a raised to power y is equal to a raised to power x minus y. So here we have 1 at the power here. So we have x 1 minus what? Minus 1 over 3 equals 16. And 1 minus is what? Plus 1 over what? 3. What will it give? 2 over what? 3. So x 2 over 3 is equal to what? 16. Is equal to 16. Now, this power here will cross here. Remember this. A is for what? M over n. And m will be that this is just the inverse of this. So which means we have x equal to cube root of what? 16 raised to power 2. Cube root of 16 raised to power 2. And 16 times 16 is what? Now we have cube root of what? 256. And cube root of 256 is what? Is 8. Cube root of 256 is 8. So let's do some workings. Five minutes of working. Now solve this. 5 minutes of work. We are done with indices. We are done with indices. Now let's move to logarithms. Just like the way we have lots of indices, we also have lots of logarithms. And lots of logarithms, low one is if log of mn is equal to log. That's if we have if m is multiplying n, if we have a multiplicative log here, if n is multiplying n, then we automatically have log m plus what? Log n. So when we have log mn, it's automatically equal to log m plus log n. Second law is if when we have log m divided by n, then it's equal to what? Log m minus log what? n. That is equal to log m all over n is equal to log m minus log n. Now the third law is log m raised to power p. Log m raised to power p is equal to, now the power of m will multiply the log. So p will come here and it will automatically turn to p log what? n. So p will come here and we'll have p log n. So p will be the coefficient of the log. Then the next law states that log base a to the power of what? 1. Anytime you see log base a to the power of 1, and when you see this, then we have 0. So the fifth law states that log base a of a is equal to what? 1. If, but this a here is greater than 0. If a here is greater than 0, then log a base a is equal to what? 1. That's if a is greater than 0. Then the sixth law, if we have log base a of b, then it will be equal to 1 all over log base b of a. If we have log base a of b, then you can also say this is equal to 1 all over, then the base and this b will switch. So the b will become the base and a will go. So log base a of b is equal to 1 over log base b of a. Now the next one is, the second law is log base a of b can also be written as log base c of b and log base c of a. So whenever you have log base a of b, you can find a new base, and change this to log base c, that's the new base of b, then log base c of a. That's the base here will not be base here. So whenever you have this, you can easily change this to this. Then we have the 8th law states that log base a raised to power r is equal to r. So whenever the base is the same with this, then and the power is r, then automatically the log is just r, is equal to r. Which means if you have something like this, log 2, 3 raised to power 4, then this is automatically 4. The same way, if you have log 3 times 2, you can simply say this is equal to log 3 plus log 2. If you have log 3 all over 2, this is equal to log 3 minus what? Log 2. That's this way. If you have log 3 raised to power 2, according to this law 3, it states that this will automatically change to 2 log what? 3. This is just it. Then if you have log 1, if you have log 2, then this is equal to what? 1. Not 2. 1. Same thing as log 10 is 10 is equal to 1. So here, if you have log 3 base 2, then we have 1 over log this will go. So we have log base 3 of 2. This will this. So let's solve some examples. Number 1, log 8 all over log 2. Log 8 all over log 2. Though this is not the same with this second loop, because this second loop is not affecting the log, it's just affecting this. Then here we have log of 8 divided by what? Log 2. Now here, we know 8 can be written as what? 2 raised to power 3. 8 can be written as what? 2 raised to power 3. So if you change this log 8 all over log 2 to be log, since this can be written as 2 all over 3, and we have log 2 here, so we can change it to this form, then this will be 2 raised to power 3 all over what? Log 2. If you check this, it's the same thing with this one. The law number 3. That numerator, log 2 raised to power 3 is the same to law number 3. And it says the power will become the coefficient multiplying everything. So we have 3 log what? 2 all over what? Log 2. And log 2 is the same with what? Log 2. So which means log 2 cancels log 2. Then we have 3 as the answer. Question number 2. We have log 81 all over log 1 all over 3. Log 81 all over log 1 all over 3. 81 is equal to 9 times what? 9. But 81 is also equal to what? 3 raised to power 4. And 3 raised to power 4 is what? 3 times 3 times what? 3 times what? 3. And 3 times 3 is what? 9. 9 times 3, 27. 27 times 3, 81. So which means we will use this because if you look at the denominator, we are having things. It's just manipulation. If you look at the denominator, we are having what? 1 all over 3. And we can change this 81 to be 3 all over 3 raised to power 4. So now this will be log 3 raised to power 4 all over 1 all over 3 is the same thing as 3 negative 1, 3 raised to power negative 1. According to laws of indices. Remember laws of indices. 3a negative 1 is equal to what? 1 all over a. A negative n is equal to what? 1 all over a raised to power n. So here we have 3 raised to power negative 1. We have 1 all over 3 and we can transform it back to 3 raised to power minus 1. So putting log 3 raised to power minus 1, we'll have this log 3 raised to power 4 all over log 3 raised to power minus 1. And this, the numerator and the denominator is still the what? The third law, if you check. We have power, and power can serve as what coefficient? Log m raised to power p is equal to what? P log m. Log m raised to power p is equal to what? Log p log m. Then we have 4 log 3 all over negative 1 log 3. So log cancel what? Log equals negative what? 4. The answer is what? Negative 4. Question number 3. Question number 3 is log 8 minus log 4 all over log 6 minus log 3. Log 8 can be written as what? 8 can be written as what? 2 raised to power 3 minus what? Log 2 raised to power 2. Now 6 can be written as what? This 6 can be written as 3.
right?
Yes.
So that the numerator will be log 8 divided by 4, right?
So let's use law number 2. Log 8 minus log 4 is the same as 8 all over 4, and log 6 minus 3 is the same thing as log 6 all over 3 using the second law. Using the second law. Now log 8 divided by 4 is what? 2. And we have log 6 divided by 3 is what? Is 2. So we have log 2 divided by what? Log 2. And log 2 cancels log 2, and we have our answer to 1. Then 4. We have log root 8 all over log 4. Log root 8 all over log 4. This square root, this will be equal to log 8 raised to a half, because there's 2 here, and we know 1, 8 is carrying the power of 1. We convert it to this low, sorry, in this, then we have what? 8 raised to a half all over what? Log 4. So log 8 can be written as what? 2 raised to power 3. So 2 raised to power 3 in bracket half all over log 2 raised to power 2 is 4. So we have this power. We will use the power with this one. So we have 3 all over 2, because 3 times a half is 3 all over 2 log 2 all over what? 2 log 2. So log 2 cancels out log 2, and we are left with what? 3 all over 2 divided by 2, which is equal to what? To change this division into multiplication, we have 3 all over 2 times 1 all over 2. To change it to multiplication. So equals 3 times 1 is what? 3, and 2 times 2 is what? 4. So our answer is 3 all over 4. 3 all over 4. Question number 5. Log 30 all over 16 minus 2 log 5 all over 8 plus log 400 all over 2, 4, 3. Now let's simplify this. Log 30 all over 16 minus, this is log, this two will go up, this is 9. So this two will go up, we'll have 5 all over 9 squared, then plus log 400 over 243. So we'll have log 30 over 16 minus log 25 over what? 81. So 9 times 9 is so plus log 400 over 243. This is log 30 over 16, log 25 over 18. Going by this law, we automatically have log 30 over 16, 30 over 16, all over 25 all over what? 81 plus log 400 all over 243, and this is now the positive law, which says that log mn is equal to log m plus log n. So converting it, we have log 30 all over 16 divided by 25 over 81 times 400 over 243. So someone should press let's break this down. Log 30 over 16 multiplied by 81 over 25, then multiplied by 400 over 243. Now 30 times 81. This one is simplification, so do 30 times 81 times 400. 30 times 81 times 400. 30 times 81 times 400. 970. 970. Log 970. 16 times 25. 16 times 25 times 243. Yeah. 96 like this. Do 30 times 81 times 400. This 972, is it 30 times 81 again? 972. No, you do 30 times 81 times 400. Do 30 times 81 times 400. This cancels this. log 973. Okay. Example 6. Let's go to example 6. Example 6. Log 10 log x base 10 equal to 3. Log 10 log x base 10 equal to 3. There is a law that says log a base b is equal to log a base b equal to c is the same thing as b equal to a raised to power c. So which means converting this to this, we have what? X equal to what? 10 raised to power 3. Log a base b, log b base a equal to c is the same thing as b equal to a raised to power c. So x is equal to 10 times 10 times 10, which is equal to what? 1,000. It's equal to 1,000. Now we have 7. Question 7. Log x log 27 base x equal to 3. So it's still the same thing. This x will carry the power of 3 and it will be equal to what? 27. Yes, 27. So x to the power of 3 is equal to 27. And what is 27? 27 can be written as what? 3 times 3 times 3, which is 3 raised to power 3. So x raised to power 3 is equal to 3 raised to power 3. Remember the law of indices that says the law of indices that says the law of indices that says x raised to power a, if x is raised to power a and y is still raised to power a, then x is equal to y. X carries the power of a, equating y raised to power a, then automatically x and y are equal. So here we have x raised to power 3 and 3 raised to power 3. It means x is equal to what? 3. X is equal to 3. So with example 8, we have log x log this x of 1 over 16 equals negative 1 over 2. This 16 can be written as what? 4 times 4 over 2 raised to power 4. So log x log 1 over 2 raised to power 4 base x is equal to negative 1 over 2. Then we have log x 2 negative 4. Remember the loop that says a negative n is equal to 1 over a n. So 1 over a n can still be equal to what? A negative a raised to power negative n. So that's what we did. So this is the same thing as 4, the third loop. 4 log x 2 raised to power 2 equals this minus a half can be written as 2 negative 1. So let's just put 1 over 2 negative, then divide both sides by what? 4. We have log x log base x 2 equals 1 over 2 divided by negative 4. This is equal to 1 over 2 times 1 over 4. This negative will cancel out. We'll have 1 over 8. Now, log x2 is equal to what? 8 negative. Then log x2 is equal to what? This is still 2 raised to power negative. Yes, this is 2 raised to power negative 4. And that says this will carry this. This is x. X 1 over 8 equals to
S is for 1 over 8.
Yes. This goes here according to the law. You have 2
That is x is for 1 over 8.
x raised to power 1 over 8.
That is the 8 root of x.
8
Root of x.
root of x.
So to remove that, then we
Taking the 8 power of both sides, because if this crosses over here, it won't be, because this is the same thing as 8 root of x equals to 2. So if 8 root goes here, x will be equal to 2 raised to power 8. And 2 raised to power x, 2 raised to power 8 is 2 times 2 times 2, 8 times, which is 256. Which is 256. 256. Period of watching. Let me give you a question. Find log of 4 or log of 2 and log 16 all over log 4. Log 4 all over log 2, log 16 all over log 4. So are you there with the working? Okay. Let's move to arithmetic progression. Arithmetic progression. So that's under sequence and series. All numbers follow sequence and series. They follow a pattern. For example, the normal counting numbers, we have 1, 2, 3, 4 to infinity. It follows what? A pattern. And what is this pattern? The pattern is to get the second number, you add what? 1. Now to get 2, you add what? 1 to this one. That will give us what? 2. To get the next number, we add what? 1 to this, we get 3. To get the next, that's the normal counting number. So all numbers follow a sequence. All the numbers have sequence. So the normal sequence for the counting numbers is what? Plus D. That's the addition of a difference. And that difference is what? 1. That's for the normal counting number. To get the next number here, we'll add 1 to 3 and we'll get what? 4 to infinity. So arithmetic progression, if A is the first term, which means here 1 is the what? First term. So it says if A is the first term, the common and D is the common difference. So if A is what? The first term and D is the what? Common difference. If A is the first term and D common difference, which means the normal counting numbers we have, 1 is the what? First term. And the common difference is what? Is D. And what is this D? D is the difference between the second number and the what? First number. Which is what? 1 for the normal counting number. So if A is the first term and D is the second term and N is the what? Last term. And here our last term is what? For the normal counting numbers, infinity. So, but for certain numbers, we'll have last term. Some numbers have last term. That's if we have boundary. Now, so if we are to rewrite this particular number, this sequence in terms of this definition, then it means our first number is what? A. That's according to this definition. Then our second number is what? A plus B. According to this definition. Our first number is what? A. Our second number is what? A plus D. And our third number is what? A plus 2D. Fourth is what? A plus 3D. And so on. Then we'll have L minus D and L as the last term. Since we define L as the last term, that's if we have last term. because for the normal counting numbers, we don't have, it is infinity. But we have a boundary. The last number is our last term. So we'll assume that we have the last term n. Then now the sum of the from this, if we want to find a formula, for calculating this type of sequence, we'll simply say the first term t, let the first term be equal, let the first term be t1, first term t1, which means t1 is equal to what? A. Now the second term t2 is equal to what? A plus what? D. The third term t3 is equal to A plus what? 2D. And the fourth term t4 equal to A plus 3D. t5 is equal to A plus 4D. Now Tn will be what? Now Tn will be A plus D plus D plus D plus D, that is 4D plus D. Then since we don't know the n term, we don't know the numbers of the numbers are in that series, then we will say this is equal to A plus n term, that's n multiplied by n minus, if you check this sequence, whenever we have 2, the coefficient of d is what? 1. If you have 3, the coefficient is what? 2. 4, 3, which means the coefficient of d is always a number lesser than what? 4, which means the coefficient of d is 4 minus 1, which means the coefficient of this will be n minus what? N minus 1. If you check, this is 2, this is d. So the coefficient of d is what? 2 minus 1, which is 1. Here is 3. 3 minus 1 is what? 2. So the coefficient of d will be what? 2. Now, n term, the coefficient of this d will be what? N minus 1. Then d. That was just, from this, we have created a formula for n, for Tn, because if you check this, the coefficient of d is always a number, is always the term minus 1, which is t3 is t3 3 minus 1 is 2, t4 4 minus 1 is 3, t5 5 minus 1 is 4. Now Tn n minus 1 times d. So the n term of the sequence is A plus n minus 1 d. That's the formula. So the formula for the arithmetic formula, arithmetic progression formula is Tn equal to A plus n minus 1 d. N minus 1 d. So so we know the formula to be what? Tn equal to what? A plus n minus 1 d. So we have, let's solve this question. The first, let's solve this question. Given this given the series, given this series, find T8. So we are asked to find what? T8, that's the 8th term of this sequence. The 8th term. So we have the first term, the second term, and the third term, but we don't have the 8th term. So we are asked to find the 8th term. And remember, the 8th term that you are asked to find is your n. That's in the formula. So the first term here is what? A. And A is equal to what? A is equal to 4. Our D is the common difference. What is the common difference? That's the difference between the second number or any number before. If you subtract 7 and 4, what do you have? You have 3. 10 minus 7 is what? It's still 3. So the common difference of this sequence is what? 3. So D is equal to what? 3. And we are asked to find what? The 8th term. So T8, which means our n is equal to what? 8. So T8 is equal to A plus what? N minus 1 close bracket D. So T8, A is the first term, 4 plus open bracket N. Our N is what? 8. So 8 minus 1. Then D is the common difference, and D is what? 3. So T8 is equal to 4 plus 8 minus 1 is what? 8 minus 1 is 7. 7 times is what? 3. So T8 is equal to 4 plus 7 times 3 is what? 21. 21 plus 4 is what? 25. So the 8th term of this sequence is what? 25. You can prove it. Since it is addition of 3. We have 4, 7, 10. The next number is going to be what? 13. The next number is going to be what? 16. Next is what? 25. Next is what? 28. So first term, second term, third term, fourth term, fifth term, sixth term, seventh term, and eighth term, and it's what? 25. And we use the formula and got what? So this is the standard formula of finding the n term of the sequence. So without, so this formula was formulated because if you are asked to find the T800 of this term, you won't have to be counting numbers. It will take you long. But if you can easily substitute it into the formula and get your answer without doing this. So our T8 is equal to what? 25. So let's stop along. Now we have the first and last term. Of are 5 and 89 respectively. find the common difference. So this one is the first and what? The first and last term. So our first term is our first term is 5, which means A is equal to 5. And our last term can be our Tn, because here we have a boundary and the last term here is 89. So we can say Tn is equal to 89. Tn is equal to 89. We are asked to find the common difference. So T1 is equal to what? A plus T1 is equal to 5. T1 is 5. In the first term. Then let's put 89 here. So we have A plus n minus 1 equals 89. And our A is what? 5. So 5 plus n minus 1 d equals 89. So A is equal to 5, that's our first term. And so T1 is 5, so it means 5 plus n minus 1 d equals Tn, and T1 is what? 5 also. 5. The last term is 9. Yes. We are not giving the number of terms in the series.
Yeah. The question
Yeah.
you have two or not? And what the question?
Yes, and it's not possible.
It's not possible.
We have another term that is missing in the equation. There's something. Missing in the equation. That's the number of terms. Yes, in the series.
The linear series.
Yes.
There's something missing in the equation. Or is there a relationship between the constant and the lifetime? Is there an equation for him? Is there a relation between the equation and the
That's the problem. The series, the number of terms in the series is not given. Let's solve the second question. A cell undergoes 9 So the first term of a sequence is 5 and the common difference is 6. Find the 10th term. So from our formula, the first term is what? Is 5. So A is equal to what? A is equal to 5. And the common difference is what? 6. D is equal to what? 6. Find the 10th term. Find the 10th term. Now T10 is equal to, oh no, that's our new. So now substituting into the formula, we have what? Tn yes, T10 is equal to, A is what? 5 and plus N is what? N is 10. 10 minus 1. D is what? D is 6. Then T10 is equal to 5 plus 10 minus 1. That is 6. So T10 is equal to 5 plus 9 times 6. That times 6. 54 plus 5. 59. So the T10th, the 10th term is what? 59 of this sequence. So this is arithmetic progression. The T10th is 59. So let's swap one and go for break. Let's define a GP transform. We have done AP and now let's define GP. Sorry, sum of AP. Sum of AP. Now, if you are asked to find the total sum of a sequence, we need a formula to find the total terms of a sequence. For example, if you have 2, 4, 6, 8, And we are asked to find the total term. The total here is what? The sum of this sequence is what? 2 plus 4 plus 6 plus 8, which is 20. So the sum of this sequence is what? 20. But we need a formula, so that if we are asked to find the sum of 30 terms or 50 terms, we don't need to be calculating it like this. So let's drive the formula. So recall that L is equal to A plus n minus 1 d. Now let sum of n term, let Sn be the sum of n term. Now, sum of n term, remember we say T1 is what? A, T2 is what? A plus D, T3 is what? A plus 2D, T4 is what? A plus 3D. And we are asked to find the sum of the terms. So the sum of the terms will be A plus D. That's this plus this. Then plus A plus 2D. Then plus A plus 3D. Continue. To the point that we'll have L minus D plus the last term. So now, since this L, since the last term substituted our Tn, then we can simply say, instead of A, we can simply say the sum of this term is equal to the sum of this term is equal to, can still be written as as L using this last L minus D plus, let's start from L. So L plus L minus D plus L minus 2D. That's the initial term because this one. So we have plus L minus what? 3D. Goes on. So if we add these two equations, adding these two equations, Sn plus Sn is what? 2Sn is equal to 2Sn. So now, if we add it, this A, it will be equal to, add this one and this one. A plus L plus A plus D plus L minus D plus A plus 2D plus L minus 2D plus A plus 3D plus L minus 3D. Continue. Then 2Sn will be equal to, if you count 1, 2, 3, 4, we have 4A plus 4L, then plus dot dot A plus L. So we have 2Sn equal to 2Sn equal to 4 all to bracket a plus f, then Sn now this is the fourth, sorry, this thing extends to n. So this is the fourth, we did for the fourth we assume that this sequence has 4 terms. That is why we are having this 4. So assuming it has n terms, then this will be equal to n a plus n. And dividing both sides by 2, we have Sn is equal to n over 2 a plus n. And remember we said what? N is equal to a plus n minus 1 d. So let's substitute it. Sn is equal to n over 2 open bracket a plus this n is equal to a plus n minus 1 d. Then our Sn is equal to n over 2. A plus a is 2a plus n minus 1 d. So this is known as the sum of an a, known as sum of an a. So this is our formula of sum of an a. Now, the first example we did, the first example of we say 2, 4, 6, 8, 10, right? And we are asked to, let's assume we are asked to find what? The sum of fifth term. The sum of fifth term. We are asked to find the sum of this term, the sum of the fifth term. So what we are going to do is, yes.
Yeah. If one of them, if you are using the last term, if you are using the last term, that means you have to use this Sn equals to n over 2. No.
This is the sum.
No.
This?
Yeah. But when you know the distance, they give
the last term
and the a.
And yes.
Okay. Okay. Then the second one, if you are giving the number of terms and
you are giving the number of terms, the common difference,
okay,
and you are asked to find the sum of the integers.
okay.
Yes. For example, this is our a. This is our a. Then we are asked to find t. Our n is 5.
Yes.
Sum of the first 5 terms.
Okay.
Yes. Then the common difference here is t2 minus t1,
Okay.
or t3 minus t2.
Okay.
Anyone. That's our common difference. So here d is equal to what? 2. D is equal to 2. A is equal to what? 2. And we are asked to find first 5 terms, which is n5, the sum of the 5 terms. So Sn, yes, Sn equal to n over 2, 2a plus n minus 1 d. So S5, because we are asked to find the first 5 terms, the sum of the first 5 terms. So S5 is equal to what? N 5 over 2 times 2, because A is what? Plus n plus 5 minus what? 1. Close bracket. Our D is what? 2. So 5 all over 2. We have 4 plus 5 minus 1 is what? 4. 2. So 5 all over 2. 4 plus 4 times 2 is what? 8. Then 5 over 2. 4 plus 8. 12. So 12 times 5. 12 times 5. Divided by 2. And 60 divided by 2 is what? 30. So the sum of the first 5 times is what? 30. If you add 2, 4, 6, 8, 10, you have 30. So, now work this out. If given sequence, 3, 9, 15. Find the sixth term. Given a sequence 3, 9, 15, find the sixth term. Use this Tn equal to A plus n minus 1 d. Work it out. Work it out. So we'll be going for 10 minutes break, and our first set of witness are done with their job here. We say thank you to you. And I've forgotten to write the registration number of this event. The reg number of this event is 23061242434LMS. This is the registration of the Guinness World Record. 23061242434LMS. So you can go for break. 10 minutes.
sa wannan numerical nan. Sura 5 minutes.
geometry progression when each is equal to the product of the preceding term and a constant factor. That is, the constant factor is called the common ratio. Consider the sequence below. 2, 4, 8, 16, 32. So, if you check, unlike the previous one, the difference is constant. If the difference is 2, if the difference is 2 here, the difference must be 2 here and must be 2 out. So, but for this one, the difference here is what? The difference between this term and this one is what? 2. The difference between this and this is 4. The difference between this and this is 8. So it's not like like arithmetic progression. Arithmetic progression, the difference is constant throughout. But this one is not constant, it changes. So 16 to 32, the difference is what? 16. So in geometry progression, we don't call it different, we call it common ratio. Because this is not constant. That's the difference between the terms. The terms are not constant. So we call it common ratio. And to get this common ratio is gotten like this. T2, remember, arithmetic progression is T2 minus what? T1. That's our D for arithmetic progression. Now for geometry progression, we have T2 all over T1 equals T3 all over T2. And T4 all over what? T3. That's the common ratio. So it means that to get the common ratio, we will divide this by this. So 4 divided by 2 is what? 2. If you divide 8 by 4, you will get what? 2. If you divide 16 by what? 8, you will get what? 2. If you divide 32 by 16, you get what? 2. So 2 is the common ratio. Now, let's find the formula connecting this. So, finding the nth term of let the first term T1 be equal to A, and the common ratio equals R, and Tn is the nth term. Now, T1 is equal to AR. Now if you check, to get this, to get the next number, we'll multiply this by what? 2. Now to get the next here, we'll multiply this by what? 2. To get 16, we'll multiply this one by what? 2. So the first term multiplied by R will give us the next term. So here we have the first term to be A raised to power 0. And I told you that R raised to power 0, anything raised to power 0 is what? 1, which is still 8. So here is 1, 8 times 1 is 8. So now the T2, our T2 will be equal to AR equal to AR 2 minus 1. T3 is equal to AR squared equal to AR3 minus 1. Then T4 is equal to AR3 AR4 minus 1. Then So, what is mitosis? Mitosis is a type of cell division that occurs in the body whereby the cell split into two. Then, after splitting into two, it will produce two distinct cells, and these two distinct cells will still split into two again, thereby giving rise to what? 4. After this, another mitosis cell division will occur. This one will still split. This one will split. This one will split. This one will split. Then we'll have what? 4 here. We'll have another what? 4. And so on. This one will split again. Split, 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 split. Here we'll be having 8. 8. Making 16. So that's how mitosis occurs in the body. So, and they say the human cell undergoes mitosis cell division. What will be the total number of cells after 4th and 8th successive division? Now, this mitosis cell division in the body follows a geometric progression. I told you that all numbers have a particular progression that they follow. And the arithmetic can be geometric. So this particular cell division follows geometric progression, because if you check, the first division is 2. Second is what? 4. Third is what? 8. 1, 2, 3, 4, 5, 6, 7, 8. So if you check 2, what's the difference between 2 and 4? We have 2. 4 and 8, we have what? 4. So it is not an arithmetic progression, because in arithmetic progression the common difference are the same throughout. So here is a geometric progression, because if you check, it follows a common ratio. 4 divided by 2 is what? This 4 divided by 2 is what? 2. This 8 divided by 4 is what? Is 2. That is the progression. So this is our common ratio, R. So first, our common ratio, R, is equal to what? 2. And our A is equal to the first division. And the first division is what? Right, 2. Then next is from the formula we have A, we have R, and we have our N. Our N is the term we are asked to find. Read the question: a human cell undergoes mitosis cell division. What will be the total number of cells after 4th successive division? So let's solve for the 4th successive division. So which means our N is what? 4. Our N is 4. So Tn equals AR n minus 1. So T4, because our N is 4, T4 equals A, which is 2, times R, which is 2, raised to the power of n minus 1. And n minus 1, our N is what? 4. So 4 minus 1 is what? 3. Now, T4 is equal to 2 times 2 raised to the power what? 3. So 2 raised to the power 3 is what? 8. So 2 times 8. And 2 times 8 is what? Is 16. Now T4 is equal to 16. So after 4th successive division, the total number of cells will be what? 16. So after 8th successive division, we have, which means our N now will be equal to what? T4 is equal to what? 16. So T8, which is A, finding T8, A is equal to 2, I think it was giving a let me just see. So let's move to equation. That would be now, like I said before, linear equation is an equation that has one unknown. That's one unknown, and the degree of the unknown is 1. Like, example, if you are given x plus 4 equals 6, this is a linear equation because it has one variable and the variable has the degree of what? 1. So this equation can be solved through either subtraction or addition, method, or collecting like time. We did similar thing earlier on. So to solve for x here, we will simply say what? Subtract what? Subtract 4 from both sides. So subtracting 4 from both sides, we have x plus 4 minus 4 equals to 6 minus what? 4, which is x equal to example, we have our AC is equal to 20. So we'll find two numbers in which if we multiply these two numbers, we will have the value AC, which is 20, for example. And if we add these two numbers, we will find B, which is this. If we add the two numbers, we will get B, and if we multiply the two numbers, we will get AC. So let me show you the clear meaning of this. For example, if you have x squared minus 10x plus 21 equals 0. X squared minus 10x plus 21 equals 0. Now x squared, here our A is what? If you are comparing this equation with this, what is our A? Someone should tell us. If you are comparing this with this, what's the value of it? Compare this with this. We have ax squared. We have something x squared. Yeah? Who is answering? Who is answering? Answer it. What's the value of a here? No, this is x squared. This is x squared. And x squared is having the coefficient of a here. That's the general equation. But in this equation, what's the value of a here? There is a value here. So the value is 1, correct? So the value is 1. And what is the value of b in this equation? The coefficient, the number attached to the x. The number attached to x squared here is what? A. The number attached to x here is what? B. The number attached, this is c, our constant. It has no x. So in this equation, what is the value of b in this equation? It's not 10. Minus 10. The value of b is what? Minus 10. And what is the value of c? The value of c is what? 21. So the value of c is 21. So if we are solving this using factorization method, it says we multiply a and c. After multiplying a and c, we find two numbers in which if we multiply them, it will give us the value of a, c, and if we add them, it will give us the value of what? B. Now, what is our a here? You say it's 1, and our b is what? Minus 10, and our c is what? 21. So what is the value of AC? AC is what? A1 times what? 21. Now 1 times 21 is what? 21. So look for two numbers in which if you multiply, it will give you 21, and if you add, it will give you minus 10. Two numbers, if you multiply them, it will give you 21, and if you add them, it will give you minus 10. So let's try 3 and what? 7. Now 3 times 7 is what? 21. 3 plus 7 is what? Is 10. 3 times 7 is 21. 3 plus 7 is 10. But our b is not 10. Our b is what? Minus 10. Now, since our b is minus 10, we will still look for if there are other available numbers. But since we are having a sign issue here, then we know that we can easily add minus to this 3 and check again. So minus 3 times 7 is what? Is minus 21, and we are having 21 here. So minus 3 and 7 is not the value. So we'll add another minus to what? 7. getting the two numbers, you create two brackets. That's factorization. You create two brackets. You put x here and you put what? X here. Our values are what? And everything equals to 0. So our first value is what? Minus 3. We put minus 3. Then the second one is what? Minus 7. So now we have two brackets that if we multiply this bracket and this bracket, we get what? 0. So which means we are just having something like a, let me use another thing, x, y equals 0. If x multiplied by y is equal to 0, it means either x is equal to 0 or y is equal to 0. One variable must be equal to 0. So it's either x is equal to 0 or y is equal to 0. So which means it's either this bracket is equal to 0 or this bracket is equal to what? 0. So the first bracket, x minus 3, is either this bracket is equal to 0 or this bracket is equal to 0. Now, if this bracket is equal to 0, we have what? X minus what? 3 equal to 0. And x is equal to what? If 3 crosses here, it will become what? Plus 3. So our x is equal to, or x minus 7 equal to 0. And if 7 cross the equality sign, it will change to what? Plus. So it's either x is equal to 3 or x is equal to what? Minus 7. Let's check if this equation is. Let's check if this equation, this answer is correct. So you see, let's use this. So x minus 3 in bracket multiplied by x minus 7. So x minus 3, x minus what? 7. Let's expand the bracket. Expansion. This will multiply this, and this will multiply this. Then this will multiply this, and this will multiply this. So x times x squared, x times minus 7 is minus 7x. Then minus 3 times x is minus 3x. Then minus 3 times minus 7 is plus 21. Because minus cancel. So plus 21. Now x squared is equal to what? Minus 7x plus 3x. So minus 7x plus 3x. Minus 7 minus 3, we say this is minus 1. 10. So minus 7x minus 3 is what? Is minus 10x. So minus 10x plus 21. If you check, it's the same thing as this question. This is our initial question. So we check the answer and brings us back to the question. So which means our answers are correct. It's either x equals 0 or what? X equals 7. That's factorization. But funny enough, as you see this factorization, you cannot use factorization to solve some quadratic equations. There are only some unique questions that you can solve in factorization method. Such type of question that have two AC is what? Our AC is what? What is the coefficient of A? And what is the coefficient of S squared? From this general formula. This general formula. What is our A? From this general formula, what is A? A is what? 2. What is B? If you look at see the equation, see this one, compare it. What is B? Now what is C? C is equal to 2. So AC is equal to what? 2 times what? 2, which is equal to what? 4. Now, if you look at this carefully, you can never get two numbers. You can never get two numbers in which if you multiply them, it will give you 4, and if you add them, it will give you 7. You can never get it. If you try 7, if you try 2 times 2, you get 4. Or if you add 2 and 2, you get what? 2, not 7. If you try 4 times 1, you get what? 4. If you add 4 and 1, you get what? 5. You can never get numbers that add up to what? 7. So this type of equation cannot be solved using what? Factorization method. You can only use other methods. You can never solve this type of equation using factorization methods. So let's solve one before next set of equations. So now, the next question is what? A squared, example 2. You are feeling you can stand up. Just stand up for some minutes. Example 2. Example 2, we have A squared plus A minus 6 equal to 0. And don't be confused because we use A here. Because if you are trying to compare this with this, you may confuse with A squared plus BX plus C equals to 0. So the value of our A here, this A is different from this. So what is our A here? Is 1. Our A here is what? 1. Our B is what? 1. And our C is minus 6. And our AC is equal to 1 times minus 6, which is minus 6. Now, find two numbers in which if you multiply them, it will give you minus 6. And if you add them, it will give you B. And our B is 1. Two numbers. If you multiply them, it will give you minus 6. Just find two numbers. Two numbers in which if you multiply them, you will get minus 6, and if you add them, you will get B, which is 1. We have 3 and 2. 3 and 2. If you multiply 3 and 2, you get what? 6, but it's not minus 6. So let's put the minus here. So minus 2 and what? 3. 3 times minus 2 is what? Minus 6. Now 3 plus minus 2 is what? 1. That's 3 plus minus 2. Plus times minus is minus 2, which is 1. So which means the values are minus 2 and 3 and 3. So since the values are minus 2 and 3, we will create what? 2 brackets. Create 2 brackets. Where 2 brackets A. Remember our variable is not X now. Our variable is what? A. So we'll put A here, close the bracket, open another bracket, put what? A. So the first value we got is what? Minus 2. And the second is what? Is plus 3. So either this bracket is A minus 2 cross the equality sign, we should change to what? 2, or A is equal to minus 2. Therefore, A is equal to 2 comma minus 3. If you expand this bracket, you will get this equation. So A is 2 and O minus 3. A is 2, O minus 3. So let me give you A. Always compare, if you are solving using factorization method, always compare your equation with the standard equation. Ax squared plus what? Bx plus c. Some of you are seeing these numbers as just, you are seeing them as just numbers, but these numbers are simulated to create your gadget that you are using. A simple gadget like your phones, everything you are using. Science made. These numbers is used in converting them. But you just don't know how these numbers are used in simulating all these equipment we are having. The phones you use are made of numbers. These numbers are important. So always compare this equation with the general equation. So the general equation is Ax. This is coefficient. Any number attached to an unknown or a variable, any number attached to an unknown or a variable is called a coefficient. So the coefficient of x squared here is what? The coefficient of x here is what? B. Now this c is carrying x raised to power 0. This c, it has x raised to power 0. But remember we said x raised to power 0 is what? 1. That is why you are not seeing the x there. But the c is carrying x raised to power 0. But since x raised to power 0 is 1 and anything multiplied by 1 is that same number or variable, then we leave it like that. So our a here is what? Our a here is 2. Our b is what? Our b is 7 and our c is what? 5. Then the next thing is what? Someone should tell us what's the next thing to do after identifying our A, B, and C. What's the next thing to do? The next thing to do is to multiply A by C. Thank you. So to multiply A, we are multiplying A and C. And now multiply A and C gives us 2 times what? 5, which is 10. So now we'll find two numbers in which when we multiply them we'll get what? 10. And when we divide them we'll get what? When we add them we'll get what? 7. B. B is equal to 7. Find two numbers. When you multiply them you get 10, and when you add them you get what? 7. Two numbers. It's even on the board. Most at times, it's even on the board. You're not just seeing it. Most at times, the value of your AC is the number. Most at times, the value of that A and C is that those numbers can give you. Check. We are having 2 and 5 here. So if you do 2 and 5, you get what? 10. If you add 2 and 5, you get what? 7. Most at times, the answer is this. But sometimes this cannot be done. Cannot be because we just have this case for now. But for example, you still have some numbers that if you multiply you get 10. Numbers like 10 times 1. 10 times 1 is 10. But if you add it, we're getting 11 and we're having B as 7. So 2 and 5 is what? 10. So now you create what? The next thing to do is to create what? 2 brackets. The first bracket will be what's our variable here? What will we put in the first bracket? What is even our variable in this equation? What is variable? Unknown. The number you are looking for. The unknown you are looking for. So what is it? What is the variable? So initial question we're having variables like x and a. But in this particular question, what is the variable? T. So the variable is t. So it is t we have to write here. T. And what? T. And we have 2 and what? 5. Which is plus 2 and what? Plus 5. So we'll just write plus 2 and plus 5. This is the most easiest equation. If you equate it to 0, we'll have t plus 2 equal to 0. Or t plus 5 equals. And from here, we have t equal to what? Minus plus 2 causes the equality sign. is more than 1. If the coefficient of x squared is more than 1, divide the whole expression by the coefficient of x. That is, if the coefficient of this, that's if a is greater than what? 1, then you divide everything by what? By a. If a is greater than 1, now, this is what we are left with. So since these two are carrying square, we can simply say n plus 5 all over 4 squared plus what? 10 plus 5 squared is what? 25 all over 4. Now m plus 5 all over 4 squared, this is equal squared is 1. 3 squared is what? 9. So minus 1 all over 9. So b minus 1 all over 3 equals squared equals 9 minus 1 all over 9. So taking the LCM, this is all over 1. So 9 here, 9 divided by 1 is 9. 9 times 9 is what? 81. Minus 9 divided by 9 is what? divide 2 by a. Now we have ax squared all over a plus what? Bx all over what? A equals minus c all over what? A. Now a cancel a, we have what? X squared plus b all over ax equals c minus c all over a. Now the next step says we should find the half of what? The coefficient of x, which is b all over what? All over a. The half of it this time is what? 1 all over 2. And which will give us what? B times 1 is what? B. A times 2 is what? 2a. So we have b times 2a. Now we will square it and what? Add it to both sides. Now x squared plus b all over ax plus what? B all over 2a squared equals minus c all over a plus what? B all over 2a squared. So this becomes x plus what? B all over 2a close bracket squared equals negative c all over a plus b. Now the square of b is what? Let's expand it. Let's open the bracket. Square of b is what? B squared. Square of 2a is what? Is 2a times what? 2a, which is what? 2 times 2 is what? A times a is what? Now 2a times 2a is what? 4. So it's 4a squared. 4a squared. Now we can take the LCM here because these are two fractions. To merge them so that they can become one, we'll take the what? LCM. That's taking the LCM. You know how to take LCM. This is 4a squared. This is a. A can go into this 1. A can go here how many times? 2. Leaving out a again, you put a here, sorry 4a, you put a again, this is still 1, and this is 4, put 4 here. So the SM is what? 4a squared, because 4 times a times a. So the SM is 4a squared. Now 4a squared divided by a. 4a squared divided by what? A is what? 4a squared. This is indices. That's why I started with indices in the morning. Because you'll be using all these things. I started with expansion, substitution, simplification, so that with this knowledge, anyway, anything we are solving in mathematics, all these things will come up. This is indices, if you remember. Indices, I said a to the power of what? X divided by a to the power of y is equal to a x plus what? N. If it is division, x minus what? Y. If it is multiplication, ax times ay is what? Ax plus what? Y. This is what I said in the morning. And this is what we are having. A squared divided by, because this side is division, divided by what? A. And a squared divided by a, that a is carrying what? Power of what? 1. And since it's carrying power of 1, it means a is raised to power 2 minus 1. And a raised to power 2 minus 1. 2 minus 1 is what? 1. Which means a is to the power of what? 1. A is to the power of 1. So it means 4a squared divided by a. This a will cancel this. And we'll be left with what? 4 and what? A. And 4a, after dividing this and this, then you multiply by this. Now 4a multiplied by minus c is what? Minus 4ac. Now 4a squared divided by 4a squared. 4a squared divided by 4a squared is 1. So 1 times b squared is what? This is positive plus what? B squared. Now equals change what? Negative. So x is equal to negative. And I told you whenever we are introducing square root, we put what? Plus or minus. Now, negative what? B all over what? 2a plus or minus square root of. Now, you can rearrange this. This is the same thing as what? B squared minus what? 4ac. It's the same thing as just rearrange. All over what? 4a squared. A is, we'll use first plus 1 plus 5 divided by 2. And 1 plus 5 divided by 2 is what? 1 plus 5 is what? 6 divided by 2 is what? 3. Already the answer is minus 4 and 3. Yes. The answer we solve here. So this is 3. So the next is what? 1 minus what? 5 all over what? 2. 1 minus 5 is what? Minus 4. And minus 4 divided by 2 is what? Minus. You see? We are back to. We solve it using factorization. But now we are solving using what? Quadratic formula. That one is the most easiest because you are just going to substitute everything and just give your answer. So it's the most easiest method of solving quadratic equation. And when we solve this one with factorization method, we got what? 3 all over. We'll get 3 and what? 7 as our answer. When we solve it with this method earlier on. So let's solve it with quadratic formula. This is s squared. What is the value of a here? What is the value of a? 1. What is the value of b? The value of b minus 10. What's the value of c? 21. So using this formula, anywhere we see b, we'll put what? Minus what? 10. And anywhere we see a, we'll put what? 1. Anywhere we see c, we'll put 21. So this is the formula x equals to b. So what will you put here? Minus 10. Then plus or minus. Now plus or minus square root of b squared, which means minus 10 squared. So minus 10 squared. What's here? Minus. Put the minus. Then next thing is what? 4ac. We'll put the 4. And our a is what? 1. And our c is what? 21. All over 2a. All over what? 2a. And 2 times a is what? Times is 1. So x is equal to minus 10 plus or minus square root of. What is the square of minus 10? Minus 10 is what? Minus 10 times 1 is equal to what? Minus 10. We use what? Plus first. Then 4 all over what? 2. So minus 10 plus 4 is minus 6. Minus is what? Minus 6 divided by 2 is what? Minus 3. Then what? X2 is what? Minus 10 minus what? 4, which is equal to what? All over 2, which is equal to what? Minus 14 all over what? 2, which is equal to minus what? 7. You know, here we're having 3 and what? 7. But here we're having minus 3 and what? Minus. Do you know why? Do you know why we're having this problem? Who can tell me the reason why we're having this problem? Why these numbers are not corresponding to the ones we found using factorization? They are supposed to be the same. Here we're having negative. The reason here is that from the quadratic formula, there is a minus sign here. So we solve it without the word minus sign. From the quadratic formula, it is not b, it is minus b plus or minus square root of b squared. So automatically there is a minus here, 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 which automatically makes it plus here. So here will be plus, here will be plus, here will be plus. So 10 plus 4 is what? 14. 14 divided by 2 is what? 7. So here, if here is plus, then 10 minus 4 is Let's solve it. Our A is what? B is what? Minus. And C is what? Minus 35. Minus 35. So from the formula, we have x minus b plus or minus square root of what? B squared minus 4ac over 2a. So, what is our b? Minus, what is our b? Minus what? Minus 9 plus or minus square root of what? B squared. Square root of what? B squared. And B squared is what? Minus 9 squared. Minus 4ac all over 2. Sorry, so minus 4. What is our A? 2. What is our C? Minus 5. All over 2. What is our A? 2. X equal to minus 9 plus or minus square root of minus 9 squared minus 4 times 2 times minus 5 all over 2 times 2. X is equal to minus times minus is plus 9, which is 9. Minus times minus is what? Plus or minus square root of what? Minus 9 squared minus what? 4. What is it? But we have 4 times 2 and 4 times 2 is what? Is 8. 8 times 35 is what? 8. Is what? 280. But we have minus, so the minus will automatically cancel this minus here. If we change the sign to what? Plus. All over 2 times 2. 4. Now x is equal to 9 plus or minus square root of minus 9 times minus 9. 9 times 9 is what? 81. So minus 9 times minus 9 is what? Is 81 because minus times minus is plus, so minus 9 times minus 9 is 81. So 81 plus 280 all over 4. So x is equal to 9 plus or minus square root of 81 plus 280. 81 plus 280. 361 divided by what? 4. So first x is equal to 9 plus square root of 361 all over 4. So x is equal to, that's the first x. The second x is equal to 9 minus what? Square root of 361 all over 4. So Punch square root of 31 for me. Three six one, sorry. Square root of 361. Square, like, 19? No. Even in points, square root of 361. Square root of 361 is what? 19? Okay. 9 plus 19 all over 4 equal to 9 minus 19 all over 4. This is where I was confused because I know the answer would be what point. That's why I was. So 9 plus 19 is what? 28. 28 divided by 4 is what? 7. Okay. This one is 7. 9 minus 19 is what? 9 minus 19 is what? Minus 10 divided by 4. 2.5 bar. 10 divided by 4. 2.5 minus 2.5. So the answer is minus 2.5 and 7. Minus 2.5 and 7. Be careful when you So who amongst you got the answer the way we did? 2.5 and 7. Okay. So 2x squared plus 7x minus 11. 2x squared plus 2x squared plus 7x plus 2. 2x squared plus 7x minus 11 equals 0. 2x squared plus 7x minus 11 equals 0. Now solving using the quadratic formula, who can tell me what's our A? In this, what's our A? Our A is what? So our A is what? 2. And our B is what? 7. And our C is what? Very good. Minus 11. Our formula is what? X minus B plus or minus square root of what? B squared minus 4AC all over 2A. What is, so So now, substituting these values into this equation, we have what? X equal to minus, what is our b? 7 plus or minus square root of our b squared is 7 squared minus what? 4 times a, which is what? 2 times minus 11 all over 2. Sorry, we'll change the a now. What's the a? 2. X is equal to minus 7 plus or minus square root of 49 minus 4 times 2 times minus 11 all over 2 all over 4. X is equal to minus 7 plus or minus square root of what? 49 minus 4 times 2 is 8 times minus 11 is minus 88. Minus 88 all over what? 4. Now x is equal to minus 7 plus or minus 49 plus 88 all over 4. 49 plus 88 is what? 49 plus 88. 1. Okay. 130. 49 plus 88. 1 what? X is equal to minus 7 plus or minus square root of 137 over 4. X is equal to 7 plus or minus square root of 137 is what? Square root of 137 is what? 11 point what? 7. All over 4. All over 4. Now x is equal to 7 plus 11.7 all over 4. Or 7 minus 11.7 all over 4. Now x1 is equal to 7 plus 11.7 is what? 7 plus 11.7.
18.7.
Now 18.7 divided by 4 is what?
4.6.
Read again. Read again. 18.7 divided by 4.
4.675.
4.675. Then x2 is what? 7 minus 11.7 all over 4. 7 minus 11.7 all over 4. 3. Wait, x squared is equal to 7 minus 11.7 is what? Minus 4.7 all over 4. Now x squared is what? Minus 4.7 all over 4 is what? Minus 4.7 all over 4 is what? Minus 1.175. So this is the solution to this quadratic equation. Now, factorization, we are done with what? Factorization, completing the squares, quadratic formula, graphical method, stop at quadratic formula. Now, there are word problems. There are word problems leading to quadratic equation. Word problems leading to quadratic equation. So word problems leading to quadratic Now when solving word problems that will lead to any form of equation, use rule. These rules should be followed. Represent the unknown quantity with a letter. Represent the unknown quantity with a letter. That's, if there's an unknown quantity, you represent it with what? Any letter of your choice. Now, secondly, express the given statement to form a desirable equation. Now, then you solve for the word unknown and check your solution. So, let's see here. Now, the area of a rectangle, the area of a rectangle is 360 centimeter square, and its length is 2 centimeter, and its length is 2 centimeter. Okay, it's 2 centimeter more than its width. Now find the width. What was it? The area of a rectangle is 360 centimeters square, and its length is what? 2 centimeters. Now first, this is how a rectangle looks like. The length is greater than the order. The width is greater than the length. So, or either way. So this shape, this rectangle has a formula. That's the formula for area. It has the formula for perimeter, and the formula of the area is what? A equal to length times breadth, which is LB. So the area of the rectangle is 360 centimeters, and its length is 2 centimeters more. Which means if you know the width, then you should be able to know the length. If you know the width, you should be able to know the length, because they told you the length is what? 2 centimeters more than the. So now if the width is 10, what would be the, for example, if the width is 10, what would be the length? The length is 2 centimeters more than the width. If the width is 10, what is the length? It is 2 centimeters more than. Then the length will be 10 plus 2, because it is 2 centimeters more than the width. That's why in solving word problem, they say what? Represent the unknown with a letter. Express the given statement. You have to express the given statement. Understand the statement. It says what? 2 centimeters more than the what? Than its width. So now, which means our unknown now is the width. Because once we are able to find the width, we will know the length. So now, then you say let the what? Width be x. You choose x, you can choose anything. So let the width be what? X. And if the width is x, they say the length is 2 centimeters more than the what? Width. So if the width is x, what is the length? If the width is, I said if the width is 10 before, what is the length? They say 2 centimeters more. So 10 plus 2. So now if we say let the width be what? Because we want to know the real value of the width. So let the width be what? X. If the width is x, what is 2 centimeters more? What is the width? What is the length? The length is x plus 2. So our width is what? X, and our length is what? from this formula of the area, it says area is equal to what? L times what? B. Area is equal to what? L times B. Now, since we know the length and we know the what? Width. So area is equal to what? And the area is given. If you look at the equation, it says what? The area of the rectangle is what? 360 centimeters squared. So now, what is our length? Our length is what? X plus 2. So x plus 2 multiplied by our breadth. What is our breadth? X. Then what? Then equal to area. What is our area? 360. Now you are formed an equation. You are formed this is a quadratic equation. Because if you expand this, you are having x squared plus 2x, because x will multiply everything in the bracket. X times x is what? X squared. X times 2x equal to 360. And x squared plus 2x minus 360, because if 360 cross the equality sign, it changes to minus. This 360 equal to 0. This is now a quadratic equation. So this is how you express, this is how you solve what problem leading to what? Quadratic. So now since we have the quadratic expression, now what is our A in this quadratic expression? What is our A? Our A is 1, our B is what? 2, and our C is what? Minus 360. Now include this inside this formula. Get the exact value of x. If you impute it, we will have x equal to minus b, and our b is what? 2. So minus 2 plus or minus square root of b squared, square root of b squared, which is 2 squared plus what? So minus 4 times a times c, which is negative 360, all over 2 times a. So now, x equal to minus 2 plus or minus square root of 2 squared is what? 4. Minus 4 times 1 is what? 4. So, minus 4 times minus 360. Just press 4 times 360 first. 4 times 360. 4 times 360. 1,401. Minus times minus is what? Plus. Are you sure it is 1,440? All over what? 2. Now x is equal to minus 2 plus or minus square root of this plus this is what? 1,444 divided by 1, 2. Now x is equal to minus 2 plus or minus square root of 1,444. Square root of 1,444. That's it. 38 all over 2. So x is equal to what? The first x. Sorry, plus 30 all over 2. And this is 36 because minus 2 plus 38 is 38 minus 2, which is 36 divided by what? 2. And 36 divided by 2 is what? 18 centimeters. Now the second x is what? X equals minus 2 minus what? Minus 2 minus 38 all over 2, which is minus 40 all over 2, which is what? Minus 20. And you know we cannot get the length to be equal to what? Our length can never be negative. So the x2 will be negligible. So the first x is what? 18 centimeters, which means, remember we said let the width be what? X, which means our x is what? 18 centimeters, which means the width is now what? The width is now 16 centimeters. So width is equal to 18 centimeters. Now the length will be what? The length will be, they say the length is what? 2 2 centimeter more than the width. 2 centimeter more than the what? Width. So the width will be what? 20 centimeter. 20 centimeter. And initial our area is what? 360. So this is our answer, which is 18 centimeter, length is 20 centimeter. Then the criteria of solving what problem is it, after you solve it, check. So how are we going to check? Now, since we know that the area of a rectangle is what? Width times length. If we multiply 18 with 20 and it gives us 360, then we are correct. Now, multiply 18 by 20. 360. So, we are correct. So this is a typical example of what problem leading to quadratic equation. Now, rest of our law. Be careful. A father is 28 years older than his son. Example. Example 2. The father is 28 years older. 28 years older than his son. The father is 28 years older than his son. In 2 years' time, in 2 years' time, he will be 3 times. He will be 3 times. He will be 3 times as old as his son. Find their present ages. Find their present age. The father is 28 years older than his son. In 2 years' time, he will be 3 times as old as his son. Find their present age. The father is 28 years older than his son. So here, if we know the age of the son, we automatically know the age of the father, because the first statement says the father is 28 years older than the son, which means if his son is 10 years, then the father is what? 38 years. Because he's 28 years older than his son. So which means our unknown is the son's age. So let the son's age be x. Let the son's age be x. Now a father is 28 years older than his son. In 2 years' time, he will be 3 times as. So now, first statement. Statement 1. Statement 1 says the father is 20. So now since the age of the son is x, then The first statement is just like this mathematically. The first statement is x plus what? 28. Because when we know the age of the son, we'll just add 28 and we'll get the age of the father. So the first statement, a father is 28 years older than his son, is represented mathematically as x plus 28. Now, the second statement says in 2 years' time, he will be 3 times as old as his son. So in 2 years' time, this boy will be, in 2 years' time, the son will be what? X plus 2 years old. It will be x plus what? 2 years, in 2 years' time. And in 2 years' time, the father will be what? The father will be what? 3 times as old as his son. In 2 years' time, the father will be what? 3 times as old as his son. The father is 28 years old, older than his son. In 2 years' time, he will be 3 times as old as his son. Find their present age. Now, since this is the first statement, my father is 28 years older than his son. In 2 years' time, this is now the father's age. So in 2 years' time, the son, in 2 years' time, he will be 3 times as old as his son, which is this. Find their present age. So this is the age of the son in 2 years. In 2 years' time. So we have to find their current age. So it's like a big equation on that simultaneous. This is a simultaneous. Our quadrant. The product of the ages of father and son father if the father is falling older than the son, find their present the product of the ages of the father and the son is 1.4. So now, if the father is older than the son, find their present age. So the father is what? Let the son's age be what? Let the son's age be x. Now x plus 24 is equal to the father's age. So you see the product of their ages is what? 144. So x multiplied by x plus 24 is equal to what? 144. That's the statement. The product of the ages of the father and son is 144. If the father is 24 years older than the son, find their present age. So let the son's age be x. X plus 24 is the father's age because the father is 24 years older than his son. Now the product of their age is 144. So we multiply the father's age mathematically with the son's age. And this is what we got. And x times x is what? X squared plus x times 24 is 24x equals 144. So x squared plus 24x minus 144 is equal to 0. Now if this is equal to 0, this is now a quadratic equation. So you are going to include this into this formula. So imputing it into the formula, we have x equals minus b minus, which means minus 24 plus or minus square root of 24 squared minus 4 times a times 144 all over 2 times 1. So x is equal to minus 2 minus 24 plus or minus square root of 24 squared is what? 24 times 24. 24 times 24. 576 minus what? 4 times 144. 4 times 144. 4 times 144. 576 again. Plus 576. Now all over 2. X equal to minus 24 plus or minus square root of 576 plus 576. 576 plus 576. All over 2. Now square root of 1,500 150 is what? Square root of 1,150 is what? 33.9 all over 2. Now x is equal to minus 24 plus or minus. Okay, let's solve for just x. 33.9 whole over 2. So you can complete this. Time for exercise. So, let's work something. Let me give you a question. Okay. A number walk. a number is subtracted from 20, a number is subtracted from 20 and from 17 and from 17. The product of the numbers obtained is 180. The product of the numbers obtained is 180. The product of the numbers obtained is 180. Find the original number. Find the original number. So sorry. The number is subtracted from 20 and from 17. The product of the number obtained is 180. Find the original number. What we need. family. So your time is up. Let's solve it and see how many of you got this correct. Now solution. A number is subtracted from 20 and from 17. The product of the numbers obtained is 80. Find the original number. Now let the number be what? X. Now you can use any value. So now let's say let the number be y. Now let the number be y. And you see a number is subtracted from 20. We don't know this number, but you see the number is subtracted from 20 and from 17. And after the subtraction, the product of these numbers obtained is 180. Find the original number. Now, if the number is y, then the second statement, then from the first statement, it says a number is subtracted from 20. So 20 minus what? Y. And the second number is 17. 17 minus what? Y. So they say these numbers, the product obtained is 180. And what is product? Product means what? Multiplication. Product means multiplication. So it means 20 minus y times 17 minus what? Y. Which is equal to what? 180. After subtracting the unknown number, they got, and multiplying these two numbers, they got what? 180. This is the mathematical expression. Now, from this, you can simply express it in a quadratic form by expanding the bracket. Now, expanding the bracket, 20 will multiply 17, 20 will multiply y, minus y will multiply 17, minus y will multiply minus y. So 20 multiplied by 17 is what? 20 multiplied by 17 is what? 20 multiplied by 17?
340.
340. So we have 340. Now 20 times minus y is what? Minus 20y. Minus y times 17 is what? Minus 17y. And minus y times minus y is what? Plus y squared. Because minus will cancel minus. So equals 180. Now, minus 20y minus 17y is minus what? 37y. So 340 minus 37y plus y squared is equal to 180. Now, rearranging it to look, let us express it in quadratic form. We get y squared minus 37y plus 340. 180 will cross the equality sign and change to 1 minus 180 equals 0. So y squared minus 37y plus 340 minus, okay, 340 minus 180. 340 minus 180. 160 equals 0. Now, our a here is what? We are expressing it in this form, the quadratic formula. Our a is what? 1. Our b is what? Minus 37. And our c is what? 160. Now let's put this into this quadratic formula. We have y, our unknown is not x, it's y. So we have y equals minus b plus or minus square root of b squared minus 4ac all over what? 2a, and y is equal to minus b is minus open bracket minus 37 close bracket plus or minus square root of minus 37 squared minus 4 times a is 1 and b is what? And c is what? 160 all over 2 times a. 2 times a is 1. So y is 2. Y is equal to minus times minus is plus. So we have plus 37 plus or minus square root of minus 37 squared is what? Minus 37 squared. minus 37 squared. 37 times 37. 37 times 37. 37 times 37. 1,369 minus 4 times 160. 4 times 160. Yeah? 160 times what? Okay, yes. Because 6 times 4 is 24, 2, 640. What about 2? 37 plus or minus 130. Do the subtraction. 1369 minus 640. 729. So 729 all over what? To square root of 729. Square root 27. So 37 plus or minus 27 all over 2. Y is equal. So y1 is what? 37 plus 27 divided by 2. So 37 plus 27 is 64. 64 divided by 2 is 32. Then y2 is equal to 37 minus 27, which is 10 divided by 2, which is 5. So our y1 is 32, y2 is what? 5. Now let's come back. The last step is to what? Check. So now let's come back and see. They say a number is subtracted. They say a number is subtracted from what? From 20 and 17, and their product gives what? 180. Now, let's assume the number is 5. Now let's subtract 5 from 20. 20 minus 5 is what? 20 minus 5 is 15 times 17 minus 5. This is the statement. 20 minus y, 17 minus y. If you multiply, they say it will give you 180. And we have gotten the value of y. So this 20 minus y is what? 20 minus y, and our y is, assuming our y is 5, then multiply by 17 minus what? 5. 20 minus 5 is what? 15 times 17 minus 5 is what? 4. 4 times 15 or 15 times 12 is what?
180.
So we check for the first one. So now let's assume the number is 30. To give us 180, which means the first value of y is what? Is correct. So now let's check for value of y equals to 32. So now 20 minus 32 and 17 minus 32. Now 20 minus 32 is what? Minus 4 times 17 minus 32 is minus 15. Minus 15 times is still the same thing. Because minus will cancel minus, we will be left with the same 12 times 2, which is 1. So we have checked. That's who amongst you got 500? Now, let's move to simultaneous equation. About you need to work class, okay, this is the latest step. And let's do simultaneous equation. So I'm done with this. First, I thought about linear equation, and I told you that linear equation has only one one unknown, and the degree of a linear equation is what? The degree. That's the power of a linear equation is what? Is 1. Is 1. So the degree of what? Quadratic equation is what? Is 2. Now, simultaneous equation. No, it's not. It cannot be. 3 is a cubic equation. 4 is a quartic equation. So, for simultaneous equation is an equation whereby you have two unknowns. Instead of having just x and a degree, or just one unknown and a degree, you'll be having two unknowns, maybe x and y inside the same equation. So it's no longer a degree, but there is x, you have y. So that's what is called simultaneous equation. The one that is having power 3 is cubic. The one having power 4 is what? Quartic. And anything from cubic upward is polynomial. It's called polynomial equation. So we'll be touching simultaneous and there are plenty, unlike quadratic equation. Quadratic equation has what? Four methods, which is I think the method quadratic equation. 1, factorization. 2, completing the squares. 3, quadratic, yeah, that's almighty formula. Then 4, graphical. But then simultaneous equation has different. It has like more than 21. Secondary school, you will be taught, they will only teach you 3. That is substitution method and elimination method. If you go higher, you have like 21 methods. You have Joda-Seidel, many methods. And we have matrix method, row echelon method. We have graphical also. We have backward substitution. Like 21 methods, but we will be touching the 3 methods plus Guava-Seidel later, not now. So, simultaneous equation. This is an equation involving 2 variables. We have elimination method and what? Substitution method. Now, elimination method, to eliminate any of the 2 variables to make a variable equal in value in both equations. Now, substitution method, you make one of the variables the relation, the subject relation. Elimination method, eliminate any of, okay, simultaneous. Simultaneous equation. 1 method. We have elimination method, and we have substitution method. Now this is a typical form of simultaneous equation. X plus y equal to 10. Then 2x plus 3y equal to 27. This is how simultaneous. It comes in pairs like this. So you have what? 2 unknowns. And to get the value of unknown is either use elimination method or what? Substitution method. Now let's try elimination method first. First example. Example 1. Example 1. X plus 2y equals 7. 2x plus y equals 10. Now this is a simultaneous equation. How do you solve a simultaneous equation? Using elimination method. Elimination method is you eliminate one variable and you'll be left with what? One variable. Then find the answer of one variable, then perform substitution method and get the other variable. This is x plus 2y. Now, if we want to eliminate x, the only way we can eliminate x, for example, if we want to eliminate x, the only way we can eliminate x is for us to get here, the coefficient of x here to be what? 2x, and the down one is also 2x. So 2x minus 2x is what? 0. So we have eliminated x. But here, the first equation has no 2 on top. So how do we manipulate the first equation to have 2? We multiply 2 by what? By 2. Multiplying 2 by 2, that's the first equation. This is equation 1. This is equation 2. Multiply equation 1 by 2. 2 times x, 2x, plus 2 times 2y, 4y, equals 2 times 7, 14. Now, the down one is 2x plus what? Y equals 10. Now, subtract the equation. 2x minus 2x is what? 0. So we have eliminated x. So here is 0. So 4y minus y. 4y minus y is what? Plus 3y equals 14 minus 10 is 4. So we are left with 3y equals 4. And y is equal, dividing both sides by what? 3. 3 cancel 3. Y is equal to 4 all over 3. Well, this is the value of y. But what is the value of x? Now you carry this value of y, substitute in any equation above, you will get what? X. Now, anywhere you see y in equation 1, you can decide to choose any equation. You can choose equation 2 and get your answer. You can also choose equation 1 and get your answer. So let's substitute y inside equation 1. We have what? X plus 2y, which is 2 times 4 all over what? 3. You put the value of y inside any equation. Since you have already gotten the value of y, now carry the value of y, put it inside any equation. You can decide to put it here, you can decide to put it here. If you now put it here, we have x plus, instead of 2y, we have 2, 4 all over 3, because now we know that our y is what? 4 all over 3. So, all equal to what? 7. Now, x plus 2 times 4 is 8 all over 3 equals 7. Now, x plus what? 8 all over 3 equals 7. Now, 8 all over 3 will go to the other side, and it will be 7 minus what? 8 all over 3. And this, the LCM this here is 21 minus this here is 8. And we have what? 21 minus 8. 13 all over 3. So, therefore, x is equal to what? 13 all over 3. And y is equal to what? Y is equal to what? 4 all over 3. This is elimination. Now let's solve the same equation using what? Substitution method. Now using substitution method, let's choose equation 2. Using substitution method. Using substitution method, x, let's choose using substitution method on equation what? 2. Because equation 2 is looking easier. So 2x plus what? Y equals to 10. We are no longer using elimination method substitution. Now let's make y the subject formula. I told you from the beginning of this class in the morning, I told you that all the things, the introduction that I give, you will need them in the coming topics. So you see, now this thing has landed us in what? Subject formula. You remember the topic subject formula. Now we'll make y the subject formula. How do we make y the subject formula? We'll subtract what? 2x from what? Both sides. 2x plus, we'll say 2x will cross the equality sign, anyone. Minus 2x equals to 10 minus 2x. This will give us with y here. Equals 10 minus, okay, we'll be left with 10 minus what? 2x. So the value of y is what? 10 minus 2x. The value of y is what? 10 minus 2x. So we'll now take the value of y. This is equation 2. If you use equation 2 to get the value of y, then you substitute the value of y in equation 1. If you use equation 1 to get the value of y, you substitute the value of y in equation 2. So we use equation 2 to get the value of y, we'll substitute it in equation 1, which is, the equation 1 says x plus 2y equals 7. So now, x plus, instead of 2y, we'll put 2 in bracket, 10 minus what? 2x. 10 minus 2x, close the bracket, equals 7. Now, x plus 2 times 10 is 20. This is 2 times minus 2x is what? 4x equals 7. Now, x minus 4x is what? Minus 3x. So 20 minus 3x minus x minus 4x is minus 3x. So equals 7. Now 20 will go to the other side. We have 3x equals 7 minus what? 20. So minus 3x equals 7 minus 20 is what? 13. And is minus 13. And x is equal to minus 13 all over minus 3. So that x will be equal to 13. X will be equal to 13 all over 3. This is what? Substitution method. Our x is what? 13 over 3. And our x using elimination is what? 13 all over 3. So the next thing is to substitute the value of x inside this is now 3. So inside this, so y will be equal to what? 10 minus what? 2x. 2 times our x is 13 over 3. So y is equal to 10 minus 13 times 2 is what? 26 all over 3. So 26 I'll take the same 3. This is 30 minus what? 26. 30 minus 26 is what? 4 all over 3. This is 4 all over 3. Using elimination or what? Substitution. And the answers are what? The same. So these are the two methods. Either you use substitution method to find the values of your variables or unknown, or you use elimination method. And I told you at some point we have 21, more than 21 methods. Now let's move to example. Example 2. Example 2. Example 2 says 2x. Now we have another one. Different from the initial one. We have 2x plus 3y equals 5. And we have x, y equals 1. So whenever you have this, you cannot use elimination method. You only use elimination method when the two equations are of the same form. That is form of 2x plus 3y equals to what? 5. This same form. But this one you see is not in the same form with this. It's just xy equals to 1. So since it's not in the same form with this, then we'll use what? Substitution method. Substitution method. Now, this is our equation 1. This is our equation 1. 2. Now from equation 2. From equation 2. X, y is equal to 1. Make y the subject of the formula. Y is equal to 1 over x. If you make y the subject, x, y equal to 1. Divide both sides by what? X. X cancels x. Y is equal to what? 1 over x. So this is equation 3. Now equation 3. Equation 3. Put equation 3 into 1. Put equation 3 in 1. We have 2x plus 3y. Instead of writing 3y, we'll put what? 1 over x. 1 over x. 1 over what? X equals 5. Now 2x plus 3 times 1 is 3 over x equals 5. So take the same x. This is 2x squared. This is plus 3 equals 5. So this is 2x squared plus 3 equals 5x. Now 5x will come to this side. 2x squared minus 5x plus 3 equals to 0. You see? This simultaneous and quadratic equation. Simultaneous equation can lead to what? Quadratic equation. So from here, we are having what? A quadratic equation. You see? From simultaneous equation, it leads us to what? Quadratic equation. So in our quadratic equation, we know that our x is equal to minus b, and our b is what? 5 plus or minus square root of minus 5 squared minus 4 times a c, which is 3, all over 2a. X is equal to minus 5 plus or minus square root of 25 minus 24 all over, this is 4. X is equal to 5 plus or minus square root of 25 minus 24 is 1 all over 4. So x is equal to 5 plus or minus square root of 1 is what? 1 all over 4. X is equal to 5 plus 1 all over 4, which is equal to 6 all over 4. If you reduce it, you are having 3 all over 2. Or x is equal to 5 minus 1 all over 4. This is 4 all over 4. 1. This is the value of our what? X. To get the value of y, we know that y is equal to what? 1 all over 1. X. 1 over x. So y is equal to 1 over x. And our x here is what? 1. So y is equal to 1. Then the second y is equal to what? Is equal to, we will use this. 1 all over x, 3 all over 2, 3 all over 2. And if we use this, we will get 2 all over 3. Because 1 divided by 3 over 2. To change this, we need this. We say the denominator will move to the numerator and then will come down. So 2 times 1 is what? 2, which is 3. 2 over 3. Now let's move to what problem. We did what problem leading to what? Quadratic. Now let's do what problem leading to what? Simultaneous equation. Now it says the average of two numbers because two numbers is what? 7 and 3 times and 3 times and 3 times and 3 times the difference between there is 18. Find the numbers. Find the what? Numbers. So we average. How do we find average? How do we find average? Average is gotten by, if you want to find the average of two things, maybe the average of 4 and 2, you will just do 4 plus what? 2 divided by what? That's the average. This is what is called average. Average is half of that. So they just use English here. The average of two numbers is something. So now let's say, since it is simultaneous equation, we know that we have what? Two unknown, two variables. So let the variable be what? X, and let the numbers be what? Be X and what? Y. So they say the average of two numbers. These are the two numbers. So they say the average is what? The average is X plus Y all over what? 2. The average is 7. This is the mathematical form of this particular statement. The average of two numbers is 7. And 3 times the difference between them is what? 18. Now, the difference, what is the difference? Minus. So the difference between X and Y is what? 18. So now here, let's cross multiply this. So we have X plus Y cross multiply Y equals 14. If you cross multiply 2, multiply 7 with 14, this will multiply 1. And it's still the same. So X plus Y equals 14. That's equation 1. Then equation 2 is what? X minus Y equals 18. This is a what? This is the simultaneous equation. Now look at this. Before the first question, we manipulated the first example. The first example there was 2 here, but we manipulated it to cancel out what? X. We now multiply 2 by what? 2 using elimination method. But here, this question makes our work easy because this X and this X has no coefficient. Well, let me say the coefficient is what? 1. So X plus Y, X minus Y. So we just say subtract the 2 equations. Subtracting the 2 equations is what? Will give us what? X minus X is what? 0. Y minus minus Y. Y minus minus what? Y. Because this is Y. Y minus minus Y. And minus minus is what? Plus. So Y plus Y is what? 2Y. This is 2Y equals 14 minus 18 equals minus 4. So Y dividing 2 by 2, we have what? Y equals minus 4 divided by 2 is what? Minus 2. So we'll carry this equation 3. Now put equation 3 into equation what? 1. We have what? X plus, instead of Y, we'll write minus what? 2 equals 14. Now X minus 2 equals 14. Then collecting like terms, we have X equals 14 plus what? 2. And X is equal to 14 plus 2 is what? 16. So the value of Y is what? Minus 2. And the value of what? X is what? 16. The average of two numbers. Now let's check whether these answers are correct. They say the average of what? Two numbers, and the two numbers are X and Y. So our two numbers is what? Is 16 and what? Minus 2. So the average of 16 and minus 2 is what? 16 plus minus 2 all over what? 2. Now 16 plus times minus is minus 2 all over 2. Now 16 minus 2 is what? 14. 14 divided by 2 is what? 7. So the first answer is correct. The first statement is correct. Now let's check for the second statement. The difference between them is 18. So the difference between them is what? The difference of this number. The difference is 16 minus or minus 2 is what? 18. So 16 minus times minus is what? Plus 2 is equal to 16 plus 2. 18. So we check and we are correct. The answers are correct. So this is a typical example of what problem leading to simultaneous equation. What problem leading to simultaneous before I give you work, let's solve this. X plus y equals 6, 2x plus 3y equals 14. X plus y equals 6, 2x plus 3y is equal to 14. Which method do you want us to use? Let's use substitution. Let's use substitution. Now substituting this, this is equation 1, equation 2. So now, from equation 1, we have x plus y equals 6, and x is equal to what? Making x the subject. X is equal to 6 minus what? Y. This is now equation 3. Now, put equation 3. We use equation 1, but so put equation 3 into equation 1. Equation 2. I told you that if we make any variable the subject of the formula using equation 1, then we'll substitute that variable in equation 1, 2. If we use equation 2, we'll substitute the variable in equation 1. So here we use equation 1, so we are going to substitute the variable in equation 2. Now, this will be substituted in 2. So 2 is 2x. So instead of writing x, we write 6 minus what? Y. Because x is equal to 6 minus y. Then plus what? 3y equals 14. Now opening this bracket, 2 times 6 is what? 12 minus what? Minus 2y plus what? 3y equals 14. Now 12 minus 2y plus 3y is what? Is just plus y. Minus 2y plus 3y. Then there is 3y minus 2, which is y, equal to 14. Then to get y, 12 we move to the other side. So this is 14 minus what? 12. And y is equal to what? 2. Now, since y is equal to this, our equation 1. For now, put equation 4 in this equation 3. So 3 says x equal to 6 minus y. So x is equal to what? 6 minus, instead of y is what? Instead of y we put what? 2. Now x is equal to 6 minus 2. This is 4. So x is 4 and y is 2. Y is 2. different question. It says using the what? Substitution method. P is 1 over x, Q is 1 over y. Solve this simultaneous question. We can solve this separately and we can get the answer of x, the value of x and y. But in this question, it says using P equals 1 over x and Q equals 1 over y. So anywhere, that's substitution. So anywhere we see 1 over x, we'll substitute it with what? With P. Anywhere we see 1 over x, we'll substitute it with P. If we see 1 over y, we'll substitute it with what? Q. So equation 1, this is equation 1, this is equation 1. Now this is 1 over x. And they say 1 over x is equal to what? P. So this 1 over x will change to what? P minus 5 over y. This is 5 open bracket 1 over y. This particular 5 over 1 and 5 over y is the same as what? 5 in bracket 1 over y. And our 1 over y is what? Q. So this mathematical change was minus 5q equals 7. Now this is 2 all over x, and 2 all over x is the same as 2 open bracket 1 all over what? X. And 1 all over x is what? P. So this is 2p plus 1 all over y. Our 1 all over y is what? Q. And it's equal to what? 3. This is equal to 3. Let's do the elimination method. We'll multiply 2 by what? This is another new equation. This is equation 3 and this is what? Equation 4. We'll multiply 2 by what? 2. This will give us 2p minus what? 5q equals, sorry. Multiply 2 by 2. 2p minus what? 2 times 5 is what? 10q equals 2 times 7 is what? 14. So this is 2p plus q equals 3. Now let's subtract. Now subtracting this equation, we have 0 here. 10q minus, okay, minus 10q minus q. Minus 10q minus 10q minus q is minus 11q. Minus 11q. And 14 minus 3 is what? 11. Now, dividing 2 by what? Minus 11. So that q will stand alone. This cancels this. Q is equal to what? 11 divided by 11 is what? 1 minus 1 because that's negative sign. So our q is what? Minus 1. So since our q is minus 1, we will carry the value of q here and substitute it in what? And substitute it in what? And substitute it in equation 3. So in equation 3, p minus 5q is equal to 7. P minus 5q, q is minus 1, so 5 open bracket minus 1 equals 7. Then p minus 5 times minus 1 is what? Plus 5 equals 7. Then p is equal to 7 minus what? 5 plus 5 equals the equality sign. Then p is equal to 7 minus 5 is what? Is 2. So the value of p is equal to what? 2. And q is equal to minus 1. These are the value of p and q. And if you want to get the value of x and y, because we didn't get the value of x and y, we just got the value of p and q. If you want to get the value of x and y, since p is what? P is equal to 1 over x. 1 over x is equal to p. What is our p? 2. This is 2. So cross multiplying 1 times 1 under here is 1, because 2 times x is 2x. Now x is equal to, divide 2 by 2, 1 over 2. So the value of q is equal to what? 1 all over y, and q is equal to, what is the value of y? Sorry, what is the value of q? What is the value of q? Minus 1. Minus 1 equals 1 over y. Cross multiplying, we have minus y equals 1. Then divide both sides by what? Minus. The y is equal to what? Minus. Yes, y is equal to what? Minus 1.
Y is equal to minus
example 6. We have 2 raised to power x plus y equals 1. And we have 3 raised to power 2x plus y equals 27. Now this is totally different from the ones you have been seeing. This particular one is totally different because this is dealing with what? Powers. And now this is where you borrow the knowledge of what the indices we do early in the morning. You will borrow that knowledge and solve what? This example. This is 2x plus y. 2x plus y. 2 raised to power x plus y equals 1. And 3 raised to power 2x plus y equals 27. Now if you check this, remember the law of indices. The law of indices says what? Anything raised to power 1 is that number, and we remember another law that says anything raised to power 0 is what? 1. So anything raised to power 0 is what? 1. So let's try and manipulate this equation so that it will resemble, we will have 2 here, because there is another law that says 2, if there's another law that says if a is raised to power y equals a raised to power of, if a raised to power x equals a raised to power y, if the base are the same, then x is automatically equal to y. So let's manipulate it to this so that you can get this. So this is 2, this is the first equation, this is the second equation. So from the first equation, from 1, we know that this 2x plus y can still be equal to what? 2 raised to power 0. Because anything raised to power 0 is what? 1. So this is it. Now, since it is in this form, remember it says if these are the same and we have 2 here, then the powers are equal. So which means x plus y is equal to what? 0. So this is equation 1, equation 3. Now let's manipulate this one also. This is 3. This is 3 raised to power 2x plus 1y equals 27. Now we know that 3 times 3 is 9, times 3 is what? 27. So 3 in 3 places, which is 3 raised to power 3. So we'll put it here, 3 raised to power 3 is the same thing as what? 27. You see, we've manipulated this to look like this. Now, since the base are the same, then the powers are automatically equal. So it means this is now our equation 4. So now, our new equation will be x plus y equals 0 as equation 5, and 2x plus y equals 3 as equation 6. This is now simultaneous equation. We have resolved this to do this. So now, here automatically let's use substitution. Using substitution method, let's make x the subject from equation 5. Make x the subject. Making x the subject is subtracting y from what? Both sides. 0 minus y. And this cancels, and x is now the subject. Then 0 minus y is what? Minus y. This is equation 7. This is equation 7. Now put equation 7. Put equation 7 into what? Into 6. Put 7 into 6. We have what? This is equation 6. Now, anywhere we see x, we put what? Minus y. So this is 2. And we see x, we put minus y. Plus y equals 3. So this is minus 2y plus what? Y equals 3. This is minus y equals 3. And y is equal to minus 3. Now, put 3 in equation 7 to get x. X is just x equal to minus y, and x is equal to, our y is what? Minus 3. So there is a minus outside, we don't put the value of y, and x is now equal to, minus times minus is equal, x is equal to 3. So therefore, x is equal to 3, and y is equal to minus 3. You can check it and see if it's correct. Now let's check it here. This is 2 raised power x plus y. So 2 raised power x plus y, what is our x? 3. So it is 2 raised power 3 plus what? What is our y? Minus 3. So yes, plus minus 3. Now 2 raised power 3 plus minus is what? Minus 3. And 3 minus 3 is 0. Anything raised power 0 is what? Then 3 2x plus y. Let's check. Now our x is what? Our x is 3 plus our y is what? Minus 3. So now 3, this is 6 plus minus 3. This is 3, 6 plus, sorry, plus times minus is what? Minus. And this is 3. Now 3 raised to power 6 minus 3 is what? 3. And 3 times 3 raised to power 3 is what? 3 times 3 times 3, which is 27. So we are right. Let me give you blackboard. So solve this here and then it's 3. So 5 minutes. Sorry, John. Let's put this one down. Go 5 minutes. Make 3 minutes. So this is x plus y equals 10. X plus y equals 10. x plus y equals 10, and this is x minus y equals 4, minus here we have x minus x is what? 0, y minus y is what? Y minus y is 2y, and we have 2y equals 10 minus 4 equals 6, and y is equal to 6 over 2, and this is what? This is 3. So y is equal to 3. Now put 3 in equation 1, we have x plus 3 equals 10, and we have x 10 minus 3, and we have x equals to what? 7. Now x is equal to 7, and what? Y equals 3. If you take this 7 and put it here, and take this 3 and put it here, 7 plus 3 is what? Is 10. If you take this 7 and put here, 3, put it here, you have 7 minus 3, and 7 minus 3 is what? 4. That's the so we're going for this is 17.5. This is 17.44. So, who amongst you have got x equal to 7 and y equal to 3? No? So we are going for 5 minutes though. 5 minutes, so thank you. Because we have to start and cover it. Now, the next witness should come and take this. Next witness. We are going for 5 minutes break.
Bam. Look at you.
Thank you.
Good evening to you all. So, our witnesses are Officer Sunday and Officer Kenneth Babaji. You're welcome. So, last we finished, we talked about simultaneous equation and we are done. So, we'll move to cycle geometry. We'll move to cycle geometry. Cycle We'll move to circle geometry. Now, properties of a circle. Properties of a circle.